Yeah, me. I'm just going to intro now. Not here. Saturday. Hello? Is it on? Hello? Yes, welcome. So this is the second track here, and we'll have a lot of talks here. We should have gotten more space, but there's not more available. But yeah, the first speaker is Devenv Cloud, talking about GitHub Actions. So take this.
Yeah, a bit of my passion. And I remember I was with Nate in SysLab. Preset things for you, you just declare the language that you're using, a bit of like configuration, and we're just gonna handle things for you. And that was like really simple and really powerful at the time. So you can declare your language, you can create a bit of configuration, in this case different versions, and then kind of like, what do you want to test? And then GitHub Actions came out in 2018. And GitHub Actions had this benefit of having all the repositories already on GitHub, so they kind of invented a tiny bit more explicit configuration syntax that if you look, let's go through it. So the first thing they kind of like said, okay, let's trigger these workflows based on some kind of events, right? Typically that would be push or on pull requests. And then they kind of like, okay, like let's bundle the idea of what platform we are running on and also like what OS we are running on into one thing and call it, this is the runner that we are going to execute this on. All right, we also do, same as Travis CI, we support some kind of matrix, but it's more generalized, so you can kind of like iterate over a list or whatever and kind of have that as a variable. And then they introduced reusability, which is like referencing repos around the GitHub as a way to execute code. So you can see two very different approaches. Like Travis picked like kind of like, oh, let's just create a convention for let's run this thing and we're gonna maintain that. And GitHub Actions kind of shifted that and said, okay, let's do that, whatever people have in a repo, and being able to reference that across the whole ecosystem of GitHub. I think both of these have like advantages and disadvantages. We're going to talk about that later. Both of these have like advantages and disadvantages. We're going to talk about that later. We check out some source. You're probably all familiar with this, so I'm just going to speed run through this. Then we set up, in this case, Python, and we can iterate through a matrix, link the thing, and then we can run some tests. That's a pretty standard open source project. Maybe outdated example, because I'm using this Travis example as a base, but you get the idea. But there's a couple of issues that are actually I live in Lanzarote and there was a product and how is everything, and she said, well, the top request for GitHub and GitLab is that you cannot run things locally the same way as you run on CI, and that has always been the case that people were asking for that. So that's number one complaint. The second one is, like, GitHub introduced YAML as a language, which many projects do, but we all know this has a lot of limitations. I think they did a pretty good job, to be honest, but it comes with all kinds of limitations. And it has like these pre-baked OS ideas, so like you get like an Ubuntu, and if you want to run on a different version of Ubuntu, then you need to upgrade, things break, and so on. There's a bunch of them, but these are, I would say, the major ones. So if you really look at this example, what we're doing is something that's very familiar with us. For us, using Nix, we're constructing a developer environment. That's it. There's not much more than that. So yeah, the Nix kind of flips that script, and at least my CI jobs don't really configure much more beyond that. All right, so now we're going to do like a 180 turn and talk a little bit about from the other side of Nix. Like, we've been doing a lot of developer experience thinking of like, how do we simplify Nix? How do we make things easier, especially for beginners? And I think that like that is super important. There's like, don't forget that each of these learnings on the way had to be like hours of research, or don't forget that each of these learnings on the way had to be like hours of research or making decisions and so on. So like I like to, there's a lot of things to developer experience, but the main my pie to make. But if I'm a beginner, I don't care about those options. I just want to have Python running, right? I'm not opinionated at all at that stage to make that decision. And I'm probably just going to trust somebody, right? I'm going to search for a blog post or something to figure out that. There was this tweet by Jason in May, which I found really cool. And by the way, this is not to bash that there is a lot of options, right? I think it's great that people out there go and they build a lot of different types of projects when it's an experiment, and then like abandon that idea and say, hey, there's another thing. But we would have kind of like two options. We would have something like languages Python enable, and you're the boss. You tell me what that should, where we let like conventions take place, and then configuration kind of override possible options. So we've been working on Devenv for about 3 years now, with a lot of these ideas in mind. And well, this could be a talk of its own about like flakes, the pros and cons of flakes. But we've learned that we had to reinvent the interface for how we interact with Nix in order to be appealing to newcomers, in order to be appealing to Nix developers that are not maybe so enthusiastic about Nix. And this is mostly because we've heard that teams do abandon Nix because somebody is not excited about Nix on the team, and that creates friction in the team, because now you have like this, hundreds of lines of let's say, a flake, and then maybe one person wants to maintain that, maybe two. Maybe that person leaves down all of this complexity to something that is super simple to explain to people. Especially now, with some of you might use AI these days, some of you not. We can like not really know Nix language and ask AI to kind of code up something for us, so we don't have to know the syntax. I think that barrier AI at least has removed quite a bit. But we still have to write all that code and understand it at the end of the day. So the idea is that, well, exactly what the GitHub Actions did, right? We set up Python specific version, we set up some dependencies, we kind of explain, oh, we're gonna test this thing with PyTest, and well, in the case we extended a bit, and we say we're gonna use Git hooks in order to lint our project. And I think that's like the ideal case, right? If you think about it, CI usually would run a few things slightly differently, but it's still and with Devenv and Nix, you can kind of declare processes, and with Devenv and Nix, you can kind of declare processes, and then say Devenv to Docker Compose. Okay, you can pull in Docker image. In our case, we have inputs, so you can say, oh, let's reference this input and let's plug it in. Let's plug in remote repo, and we can in that way compose poly repos across each other. All right. So bringing it all together, now I can show you an example where there is difference between developer environment and CI. So in this case, we're constructing a developer environment with Python, the same thing as we did before. But we're saying, OK, how about like on the CI, I don't want to run Postgres, and locally I do. And something that is very often requested is monorepo support. So Git hooks by default will run on CI across the whole repo. And if you have like a huge project, most companies, that's going to take a really long time. So if we expose some kind of configuration that this is running now on a CI, let's say this job was triggered by GitHub, we can expose some metadata just the same way as we would do normally in Devenv with options. We can then like say, okay, these are things that are exposed that when things run on CI will have value. And we can say, well, run the Git hooks between these two Git versions, these two Git revisions, so not across the whole monorepo. And that makes CI fast suddenly. So this way we can kind of like tweak it, but it only applies to when it's run remotely. So yes, there will be a slight difference between developer environment and what runs on CI, but that is declaratively specified and pretty clear. So we're kind of mixing the two into one configuration. So now I'm going to go through a few, I would say, basic features of GitHub Actions. It's not. So one of the pet peeves of mine with GitHub Actions is it's like really hard to run things in parallel. Like usually you kind of go through different steps, but all of these steps run sequentially, and you have to like really wiggle your way through making them parallel. So in Devenv, we've developed a concept of tasks. You can think of tasks essentially Nix, but impure. So this is not running Nix, but it's still a DAG, right? It's still a dependency tree that executes. And it's pretty simple. Like you declare a task name, and you declare what it's going to run. And then with before or after, you can kind of declare what runs before one or another thing. So if you have things that should run in parallel, it will. But if things depend on each other, it's going to wait for it. It will, but if things depend on each other, it's going to wait for it. And the beauty of this is like this works. All right. You can define a task that are like that are CI specific. You can, let's say you run a job on CI, maybe some extra task. The nice thing about this, it will spawn processes. It's going to run the test. The nice thing about this, it will spawn processes. It's going to run the test, and then it's going to tear down the processes. Devenv test is going to take care of that. So set up the developer environment, include the processes, run the test, and then tear down the whole thing. Runs the same on CI, runs the same on your local machine. All right. A few more examples. So this is something we haven't implemented it because we're still looking for we're still experimenting with design. But as I've mentioned before, like GitHub Actions has the limitation of YAML as a language, as we might call it. And it works pretty well for simple cases like this. Oh, I want to like generate different CI jobs based on Python version. But if we have a real language, we have way more power environments. So the idea is you can define these kind of profiles that kind of like augment the basic developer environment. So if you see here, this will Python version 3.14. This profile will take the base config, but then override some options and kind of expose that. So you can clearly imagine that here we could use like a built-in map or something to kind of iterate through different versions and generate different profiles. And now we have the power of Nix language to kind of generate as many profiles as we want, and then we can ask CI, okay, just run through all these profiles and create different jobs for them and kind of like test this out. So there's like an issue about this, and yeah, still it's not implemented at all. Just to be clear, it's an idea exploration. So I'm curious if people have some ideas about this. I think supporting this kind of like slight modifications of development, a guide that kind of talks how to implement this without as a first-class citizen of Devenv. You can pass like on command line options. You can say like declare a profile, an NixOS option, and then pass it through. But I would like to make this a first-class feature. So yet to be done. Another one. This is not exactly not the same, but I think that a lot of what artifacts on GitHub do is kind of bundle some software, right? It tries to build some software, tries to build an installer, it tries to build I don't know what. So that's where things get a bit. Before we talked about, Travis introduced this idea of like, I don't care how you do Python, I don't care how you package Rust, right? Just do it for me, pick the best tool. So with Devenv, we kind of have two levels of how Devenv works. One is like we say, languages Rust. All right, that's going to give me a compiler, linter, all kinds of things I need to do Rust. But then maybe I want to package these things with Nix, right? Maybe I want to not just Devenv to provide the environment for me, but actually like package the whole thing using Nix. So there's all kinds of projects out there, Create to Nix, Narx, I don't know, there's probably like 10 of them. The idea in Devenv we've picked is like, okay, we're going to pick the tool for you and kind of hide it behind this uniform API and say, config languages Rust. So this is gonna pick all the configuration you possibly have there and now apply it and import this Rust application that I have there. With a attribute set there where we don't support that yet, but at some point you can override things there, right? So you can say like, oh, but I want you to have I don't know, this extra system library available or whatever when I'm importing this thing. But in this case, we don't support that yet. That will come up with time. But the idea is, okay, this is now a very simple So we have, let's say I have like Rust, Python, and Go. This is quite simple to understand what's happening here. Outputs, this is similar idea to Flakes, except in Devenv, we kind of have outputs as a specific attribute set, and here we can kind of expose different things that this environment exposes at the Nix level. In this case, we are exposing Rust and Python apps. That's something. This is a few examples. So we've developed something we call Devenv Cloud, which is completely open source, available here, written in Rust. That kind of implements this idea of GitHub Actions, but with Nix. Is one of my favorite parts of Rust ecosystem. Those that don't know it, it's like kind of like open telemetry, but built into Rust as a first-class crate or a language thing that's like used all over the ecosystem, and it's just simply amazing. So we've done a lot of stuff with it. I'm going to show some of the things in Nix, and here you can see like it will show you. Like something is building, downloading, and call all kinds of progress bars. You can like go up num or have heard of. If you invoke Devenv, the terminal interface to kind of signal something has started, something has stopped. It's going to invoke Nix, which is going to do the same. We created a bridge which parses Nix logs and then exposes that interface at the tracing level. Or we also have support for Snix, although it's not implemented yet, but the abstraction exists. And that also will use then tracing to signal back. So the idea is either Devenv, Nix, or Snix, whatever they're talking the same kind of UI interface, and so we can kind of like display UI interface, and so we can kind of like display in the terminal what each part that's being invoked is doing. Same thing that, and then the same thing happens here. So it's gonna start Devenv, and that will run Nix or Snix, and all of this will use then tracing to kind of like pipe through all that's happening through a socket back to the host, and then display this in a web interface. So this is an example for Linux, but macOS is a bit more complicated, so we'll just keep that. The idea is, yeah, for each VM we spawn a job. We use tracing to report everything back to what's happening inside the VM. But the major benefit is this environment, the Devenv spawns, is there's nothing in there. Like Devenv will construct the whole developer environment. So this is a major difference to GitHub Actions, where you are essentially polluting your environment, whatever Ubuntu provides, right? So that's where discrepancy comes from. So by default, you get core utils. That's it. That's all you get in a CI. So if I go back to previous slide, we can go from git push to evaluating in under a second, and this is without any kind of performance optimizations at all, which is kind of nice. When you think about GitHub Actions, you would usually install Nix, install Devenv or whatever. So all of these steps are executed every time you run a CI job, and it's completely not needed if you build a CI that is like Nix first. I mean, and this is excluding the Git clone, right? So this is like if you have like a huge repo, that's obviously going to take some time. But assuming you have a very small repo. All right. Did I forget about something? Right, the web interface for tracing is very basic. It's essentially not that. We always try to first do the local feature first, or do it the opposite way, and then try to always think about how does that affect the cloud, and then implement the same thing in the cloud. So that's yet to be done. This is so solutions that exist out there, but it's completely open source, so you can self-host it. It supports all of the enterprisey features. It supports passkeys. It supports one-time passwords, everything. And Devenv Cloud integrates with it. The way it works, it uses OIDC tokens to kind of expose that to the app. And then behind that, you can configure whatever SSO you want and plug it into your to re-implement Authentic from Switzerland. So it's pretty interesting. They're doing really cool stuff, I think. All right. So is it really that simple, right? Is that really yeah, like Nix solves like 80% of the problems for us, and then we just have to build a tiny bit of top of actions. Usually download a bunch of stuff, then you run some stuff, and then you upload. That is kind of unavoidable, but with a CI that is like Nix specific, what you can do, you can be smart about it, right? You can be prepared and say, okay, we're gonna make things that are frequently used less locally available, and that's all future work. But that's the benefit of having a CI that speaks Nix. So now, before I finish, I think I just want to share a bit of like the idea behind Devenv. The way I see it is like, system did a lot of great things, I think. I know some people don't like it, but I think that the fact that we don't talk about init systems, it means it's its job, and that is like a finished subject. So I have a similar vision for Devenv. I want it to absorb a lot of the different tools and pack it into one thing. That comes with the downsides, of course. That means that some decisions had to be made that could have been made differently, but they were made very thoughtfully and for a specific reason. So we kind of like explore in the future, like we want to rewrite Devenv, at least the parts that we are using. Why? The major reason is when you're working on a Nix project, like you change a Nix project and then like it just starts to rebuild like it reloads your shell if you're using Devenv and starts to build something from scratch. And that can mean like you need to suddenly wait 10 minutes for your terminal to be ready. So what we want to do is like kind of move that to the background so that it's rebuilding in the background, and when it's done, then it just reloads your shell instead of like annoying you as soon as something has changed. We have noticed that while developing on Devenv itself, that it's really annoying. And the features we're using for Devenv are very specific to Devenv, so there is no reason to have a separate tool, and we can do a lot more, but that's for the future. And the second is Process Compose. Once we have a terminal interface, right now we use Process Compose. It's a really nice terminal interface for launching different processes and being able to see logs and stuff like that. But the terminal interface you saw before, there's not much work to just also display processes that you're running in the same kind of fashion. That will give you like a nice feeling that you're using one tool for processes, for setting up Nix, and all kinds of stuff. So that's, you rewrite the ecosystem so that it works together is pretty fits Devenv well, and the more we do of that, the more we see the benefits of it. One example for process compose is like, right now you cannot use tasks to like you cannot say run this process, then when this process is ready, run this task, and then when this task finishes, start this other process, right? That is a quite complex feature, but like you might easily imagine, like, I don't know, run the database, run some migrations, and then do something else, for example. It does come up quite often in developer environments. So the only thing you can do is you can run tasks before or after a process has finished, which is already pretty helpful for like setup and tear down, but not between inter-process dependencies. All right. You don't have a mic.
I have a mic.
You have a mic.
Yeah. And before Doman wraps up, Ocean Sprint's coming back. It's a, where should I stand? It's a really nice week-long hacking event on Canary Islands, where Dom and I are staying most of the year. If you see people running around with these T-shirts, ask them how the event was, and then apply and see you in April 2026.
Yes, we don't have the dates yet, but
yeah.
All right. So finish a bit of info. So a huge disclaimer: this is alpha quality software. We are going to start private beta soon. It's open source, so you can build it and run it yourself. It's probably not going to work for you. We still have to do a lot of work. So I don't recommend doing that, just to be very explicit. And second of all, we're going to open up private beta, as I said, in a couple of days. And then we would like to see people start using it. And probably we're going to start inviting first people only after a few weeks. But we wanted to share this with everyone and to explore the code base, to explore the ideas before it's ready. And yeah, with that disclaimer, I hope we can get Nix into more things, and let's get it into GitHub Actions and GitHub. Thank you.
All right, thanks. Do we have questions? Okay, I guess first come, please.
Thanks. Great talk. Thanks. Maybe I missed it. You might have shown it, but how will it look like? Like, will I have to change my GitHub build YAML file? How will it look like in the end, or is it will it completely get rid of GitHub Actions? How?
Yeah. So the idea is if you have devenv.nix, you're rid of like conventions, right? So if you have devenv.nix, then we assume you're going to run Linux and Mac OS. But then we're going to provide knobs to like disable. Let's say you can say, okay, I don't want to run the Mac OS build. So you can get rid of like GitHub Actions. There are parts of GitHub Actions that we don't do. So GitHub Actions you can execute for all kinds of events, right? So if an issue is open, then you can execute like something. And we don't support it yet, but you can completely hook up that in the future and say you want to create a developer environments when the issue is created and then run something, right? So there is features that are also missing, just to be explicit, that it's not fully feature complete yet. But the idea is, yeah, you can get rid of GitHub of YAML files for the workflows and just use Devenv for that. That's the vision. That's not that we have to get there.
Next question. All right.
The slide with the uploading artifacts.
Oh yeah, sure.
Let's say I want to build a binary package for a distro that I won't name.
All right, that makes it harder.
So some distros like prefer dynamic linking, for example.
Right.
So Nix will patch the binary to hardcode the Nix store paths, which is why sometimes you might not want to upload or build with Nix if you need to upload binary artifacts.
Yeah.
Can you do that with Devenv?
Yeah, I think that's a great question. So like, one of the limitations of this approach is like it tries to push you into the Nix land, right? As soon as you want to escape that and kind of like do a 180, you hit into the typical limitations of Nix. Can you do that? There is a lot of projects that try to do that, right? There is like NixLD and all kinds. But you have the same limitations here, right? You have to find your way to either build a static library, right, or to patch the dynamic things. None of this does that for you, right? You still have to rely on these projects. The idea is that I hope that in the future you don't have to escape that, right? I mean, of course, in real life, we all know that there's legacy systems and all of that, and for those you will always have to do it. But I hope that in the future we can build an ecosystem where we slowly like abandon the internet.
Yeah, thanks for a great talk. I was wondering, there are some code forges like Git and ForgeJo that have almost GitHub.
Now I need to find, right. So here we kind of made a platform where the hooks are coming from. We're going to focus on the major, probably maybe GitLab, because actually these integrations are not that as complex as you think, right? You need to get data from the thing and kind of extra thing, right? You need to get data from the thing and kind of extract it, like map it into the Nix world and kind of like expose that metadata onto the job, and that's pretty much, and then kind of like use an API to report back a status or something. That is kind of like most of the work. So we're definitely not going to do it before we are happy with the GitHub part, but yeah, feel welcome to contribute that if you want.
Next question.
I think it's here and back there.
All right.
All right. Can we have a quick look at the outputs slide again?
Seems to be the popular one.
I know you said it was future work or in progress. So the Rust app and Python app entries actually caught my eye because at least at work, we don't use the Rust platform build Rust package or the Python package build Python package functions, but you use the two Nix adapters.
Right.
Right? Because you don't necessarily want to use the Nix packages, Python packages. You want to use what's in your UV lock or in your PyProject lock.
Exactly.
And perhaps I simply didn't hear it earlier, but can we somehow finagle these two Nix adapters into these import statements that we have on the bottom there?
Yeah, so actually the Python one, there is a pull request for it, and it uses UV to Nix. So the idea is like, we examine the ecosystem and we put the best tool out there that like does the best conversion. For Rust, we are using Cray2Nix. I always forget because these names are so similar, so I have to look at that. Yeah. But for Python, UV2Nix. And if a better tool comes up, we can just plug it in the background, import, so you could also implement different kinds of imports, right? Because like, let's say in JavaScript, one of the 1,000 others, so we have the flexibility to also implement others. So yeah, the answer is basically, yeah, that's the idea. And we try to pick the tools that use import from derivations, so you don't have to like generate logs and do the whole bootstrapping dance, with hopes that Nix will improve its import from derivation feature in the future.
All right. I think the
Two
time
more
is
hand.
up, or what does your timer say?
It says it's up.
It says it's up. Okay, maybe one quick one, but it also depends on you to answer.
All right, I will be quick. I can promise that.
Okay, you pick who. Who? Which one? Here?
Sorry.
No stress. A lot of my colleagues work with supporting CI and CD systems for other developers in our company. One of their asks is visibility, so they can help maintain. a solid CI and CD setup. The Rust. Is there potential to export the OTel, the traces to OTel exporters outside of this?
Basically tracing, right? And then the things we show, we extract from that and filter through. So yeah, you could then use that to leverage and plug it into something that knows about tracing and expose that and deal with that. That's not something we have done, but it can be done. That's the idea.
All right, we're done. Sorry. The people in the back are getting mad at me. Let's thank our speaker again.
All right, thank you.
Okay, everyone, let's get ready for our next talk. The music is off. Okay, quiet, please. We're late on time. I think after this we got the lunch break, so. Very nice. Very nice. Silence, okay. Great, okay, so without further ado, the next talk. Without further ado, the next talk.
Hi, nice to having so many people here. Hi, nice to having so many people here and interested in Hydra. So how many people are familiar with Hydra? The Hydra is basically our build system for Nix packages and some other smaller projects that are built currently, like PatchElf and GNU. It exists of a couple of components. Basically, the Postgres, which is a single source of truth, and it's a communication link between the produces derivations and writes builds into the database into the Postgres. Then there's the QRunner CPP. It monitors the database. It splits builds into steps, and then schedule these steps to remote builders and uploads the build outputs into the store, also into any remote store, if there's a remote store configured. Then there are the builders, the remote machines, and the Nix CPP version, the QRunner CPP version builds via the Nix protocol, and this is done via SSH. And last but not least, we also have the Hydra web UI, which you are most likely familiar with. It shows the current builds, the running builds, the latest build steps, and all of this. And it just basically queries the Postgres. It does not really talk to any of the other components. It basically always restores the local store is the Nix store, obviously. The evaluator accesses the Postgres, gets the job set into the Postgres or the build results. The QRunner monitors the Postgres queue, gets an event from Postgres, and then reads the builds table, and will then schedule. The communication of the QRunner is done currently via SSH. So there's a subprocess, so the CPP application starts a bunch of subprocesses to the remote builders using SSH, and we'll use nixstore -serve -write, which is a really low-level interface. And you can basically use pipes to write Nix protocol into the remote store, and can use this interface to schedule builds and copy outputs and stuff like this. So the QRunner does directly the Nix protocol stuff into these pipes. We currently have the problem that we can no longer handle more machines. If you just went to the State of the Union presentation, the infra team, Jörg mentioned this, that we have more machines, but we cannot bring the builds to these machines any faster. This means we have currently further scheduling issues because everything is done in one queue. The queue is also not persistent, so every time the queue is reevaluated. We have also a lot of synchronous communication with the remote store. Oh no. It will hopefully not happen again. Synchronous communication with the remote store, and we are doing this while traversing the DFOs, which takes a lot of time. So Hexa mentioned this to me privately, that if we are currently merged stages. So we decided to rewrite the Hydra QRunner on Rust 4 months ago. And who is we? Me, and also Janne. Janne is currently a maintainer of Hydra, so that's why he's here. We done this together with the Nix infra team, mainly Hexa and Mick. And thanks to the foundation, Lazarus especially, who joined every meeting, and Frickler Handwerk, who helped with some organization. And thanks to SDA, the Sovereign Technology Agency, which made this possible by providing some of the funds. So we started redesigning the Hydra QRunner. The goal for the redesign was that we wanted to support more builders, which was one of the most main goals for Hexa especially, and also for Lazarus. And we will have more builders, remote builders, that need to be connected to them, so we can build more builds. Another performance issue, like I mentioned, is the faster creation of the steps, and especially the async integration into any remote store, cleanly separated. So if you and improve maintenance so that more people can contribute, easier bugs, the most communication is done, catch the same events and write the same build information to this. We established a new builder communication protocol. We used gRPC for this. No particular reason other than this is a popular protocol that can be used for this. We are streaming NAS over this, so this new remote protocol gives us more flexibility. We basically can request the build at the QRun memory usage, which then can lead into better scheduling decisions. We use the gRPC protocol to stream the build logs at the same time as we're building them, and we stream NAS, which is mentioned twice. In theory, get rid of this because the builders are talking to the crew runner, not the other way around. In theory, get rid of this because the builders are talking to the crew runner, not the other way around. And for this, afterwards, we send a ping message basically every 10 seconds, which is the current load and stuff like this I'll mention. This gives us the scheduling monitoring benefits I talked about, CPU, memory, disk pressure, stuff like this. So for example, we are currently running the QRunner already in production at Helsinki Systems, and we sometimes have an issue that we have a full disk. So we can take this into consideration, stop scheduling builds to the runner. Go rebalance load across multiple across the builders. The internal design of the QRunner is that there are basically 3 tasks. There's the queue monitor task, which watches for any new events. So, for example, there are new builds, or builds are bumped to the front, and stuff like this. This is every time we get an event from the Postgres database, we need to take a look. These events are sent by the evaluator and the Hydra UI. And once this happens, we will reevaluate the open builds. And then there's the dispatch task. The dispatch task is this will then dispatch those builds to basically the builders. And then there's the uploader task. The uploader basically will then write it to the remote store. So we are doing this on a separate thread. And so you can limit uploads the concurrent uploads at the same time. This ensures that only one task can insert new builds into the basically internal state, and we are also this also ensures that only one task can schedule a build, because we need to ensure that the same duration is not scheduled to 2 machines at the same time, unless, for example, there's a build failure or the build got canceled. Then we are allowed to reschedule it. We then also have event-based, so everything else like the gRPC communication, like streaming the logs, is event-based, and the HTTP request, there are a couple of endpoints, additional endpoints to get information about the internal state of the QRunner. This is done via event-based. And the QRunner keeps the current builds in process. It does not write anything to the database, and about the internal state, it only writes build results to the database. And so it's triggered by a Postgres event. It then gets all open builds and the durations. It reverses the duration tree manually, so we are checking, hey, is this duration already done? So basically, we already have the outputs, or had a lot of mutexes and we write logs, but to some Postgres operations, all of this can be done asynchronously, and it generally improves the speed of new builds being scheduled. Once a step exists and is runnable, then it is inserted in a build queue. What are runnables? Let's look at this graph. So we have at the top level we have the build. The build is a DFR generated by a job set, and down there we have the dependency tree, for example. All these leaf nodes are runnable. So basically, dep is a runnable, because we no longer have any further dependencies to this. To this dependency, or to this these 2 dependencies will then be runnable. But all of this get runnable, and these jobs get then scheduled to builders. in the end, everything is built, and we have an empty build queue. So we did some more changes. Currently, there is only one queue per platform, so we have one queue prepared. This is sorted, and for all platforms. So basically, there's x68 and Darwin in the same build queue, which caused some problems. The Darwin builds are prioritized above x68, Linux, for example, and yeah. We isolated the build platforms into multiple queues, and these queues are now also sorted in a similar way, based on the priorities. For example, if you want to bump everything. The next part is the dispatch task, which triggers runnables to machines. If a runnable is already scheduled, it's not scheduled again. We then create a build step in the Postgres database. So if you ever open the build in Hydra UI, you see that there are a bunch of build steps. These are the dependencies that need to be built. The queue runner then finds a free builder. It determines this by a couple of metrics, like for example, you can say, hey, this builder can have a max job count, which is the scheduling that the old queue runner uses, or you can do some dynamic scheduling based on pressure or load. Load if you are on Darwin. Then the runnable gets linked to the builder, so we are storing the information if the builders, which builder builds which runnable. And the basic message is that we are sending the build message into the channel, also the bidirectional channel is the only way the queue runner can talk to the builder. It sends basically a build message, which this derivation with this build options, for example, the build timeout and silence timeout. Afterwards, the builder it's a separate binary, and it acts independently. It fetches the NARs and imports those into the local store from the queue runner, but only missing NAR. So if you have a local host builder, it does nothing in this part. Then it starts the build and it processes it. And once it's done, we are uploading our build results and sending information about the build. So this part can also be done at an earlier stage. For example, if the build fails or if an import fails, we are sending information about it to the queue runner that, hey, the build fails or some dependency failed or something like this, or the import failed. Depending on the build failure, there's also some logic about rescheduling, which can be configured. So you can builds are rescheduled if the import failed, but if the build itself failed, then there's no rescheduling. Some results. So the new queue runner is deployed for 8 weeks already at Helsinki Systems. We sadly don't have any remote store. We only have the stores itself, which are served via Harmonia. But this part, the remote store, was then tested in the Hydra staging. The official infra team has been staging Hydra for a couple of weeks now, and it also has the new queue for the QCheck. It's merged into the Nix community Hydra like 2 days ago, 3 days ago, which is quite exciting. They are using this in production to build Emacs overlays or something like this. And we have implemented, we are basically feature complete. This is not a half rewrite. We have all features that the old queue runner has re-implemented in Rust. The migration path is also really easy, so we are trying to get this merged in production Hydra. Clean up the database a little bit, like 32-bit timestamps. So clean up the database a little bit, like 32-bit timestamps. So the queue runner can be swapped back and forth. Because we implemented the same data, and we went back to the old queue runner for a couple of days. Some downsides that the new implementation has is that there is some protocol evaluation. This requires versioning. So if the queue runner itself chases the protocol, then all the builders need to be updated at the same time. Otherwise, they can't speak the same protocol again. And protobuf messages can be lost. So this requires, in the future, backwards compatibility fields or versioning, stuff like this, that this works easier. Also, the new queue runner has this second binary, the builder client, which increases deployment for the infra team and stuff like this, but this was evaluated. And we have a more complex authentication. Previously, we only had to share SSH keys. Now we decided to use MTLS, which requires a CA chain. A little bit more overhead, especially for people who run the Hydra queue runner locally or something. Conclusion. We did rewrite the queue-runner completely and solved the SSH scalability issues. We gained vision. And yeah, this should result into more concurrent builders. Still needs a little bit more evaluation, but yeah. We presented a smooth migration path. Outlook. We are currently working on more, also there can be more advanced scheduling policies, for example, like costs can be quite difficult to compute, for example, when a host is actually busy, or for example, you can deploy 20, 30 Python jobs to the same machine, but you can only deploy one Chromium build, for example. And we also plan on doing some work for CA derivation, getting CA derivations into Hydra in a more usable way. Thanks for your time. Any questions? No.
We're doing a lot of crazy evals because we have Haskell builds, so they become quite big and they have a lot of IFDs in them. And sometimes what happens is that because both Hydra and the IFD builds that are happening in order to eval in the evaluator, both you use the same Nix distributed builds protocol, right? Nix distributed builds protocol, right? Which is happening. We get woken up for that. Make it there's a way to make the IFD builds visible in the queue runner as well.
Currently not, but maybe this can be talked about.
Can I? Okay. Currently no, because possible, like some hooking feature, but you have to talk about that with MiG92, I think. Yeah. Possible, like some hooking feature, but you have to talk.
This is held back just by not being able to make use of compute resources. Things that are cutting out. The ability to say yes to like this will undoubtedly.
Microphone. It is working. What happened? Okay, we have. I don't know how many questions we have. I can't really see the AV team. Whatever. Okay, you're next.
I'm very curious about that.
Yeah, I plan to collect metrics, but I never actually came around to it. The new queue runner. We have some adjusted Hydras and adjusted UI in the Hydra, which shows the more advanced UI for the machines. And we are collecting more metrics, so the new queue runner has a better metrics collector and exposes those metrics through Prometheus metrics. But we never actually came around to actually collecting them for more weeks, which is a oversight.
Thanks very much. We have a lot of trouble with Hydra's queue runner. This will solve a lot of issues. You mentioned that you are now using a gRPC protocol to the builders, which is a great improvement. Yeah. Does the remote builder only talk to gRPC to the Hydra queue runner? So it's effectively rewrapping the Nix daemon protocol in gRPC. Is that
not exactly the daemon protocol, but we are basically binary about this.
Is it possible in future with this architecture to pit builders against each other? Because you mentioned that currently only one builder can get one task at a time.
Yeah. You have to get around the fact that we currently.
Yeah. All right. So let's thank our speakers again. All right, everyone. We're back. I hope you had a nice lunch break. Okay, so our next talk by Zach is titled, You Can't Spell DevShell Without Hell. So let's welcome our speaker. Welcome our speaker.
Hello, thank you for having me. Like they said, you can't spell DevShell without hell. My name is Zach Mitchell. I'm an engineer. Thank you for having me. Like they said, you can't spell DevShell without hell. My name is Zach Mitchell. I'm an engineer at Phlox, and I work primarily on the CLI where one of our commands is Phlox Activate, which is very similar to Nix Develop in the sense that it puts you into a developer shell. So what we're going to cover today is, first we're going to dive into how Nix Develop works. Then what if we want more from it? So what if you want to use a different shell? What if you want it to be faster? That kind of thing. And specifically how that's implemented in Phlox Activate. And then you'll get this as we go along. There's not a dedicated slide for this, but you'll see why Fish is objectively the best shell. And thank you, thank you. I see I'm among my own people here. Okay. So to frame this whole thing, I wanted to discuss very briefly kind of what is the purpose of a dev shell. So generally, you have some dependencies. You want those to be found before anything else that's on your system, just natively. And so what does it mean to find it? So in my mind, the observable universe to your shell kind of consists of both the file system and the environment. And so if you can control those, you can control what is observable from your shell. And so the strategy here, both for Nix Develop and Phlox Activate, is to deterministically set the environment. That's where all the whole derivation machinery comes in. And then you can manipulate the file system via symlinks, also where derivations come into play. So we're going to dive into Nix Develop right off the bat. So this is kind of a high-level overview of what the Nix Develop flow looks like. You're in your user shell, you type Nix Develop, and that forks off a new process. And what that process does is it obtains some kind of environment that's supposed to show up in your shell. We'll get into all the details of what that looks like in a minute. And then it's going to take that environment and create a RC script, run control, bash RC, that kind of thing. It's going to create an RC script to basically replace your shell's normal RC script. And once it has that, we're going to exec bash in this case. So for those of you that aren't familiar with fork exec and system calls like that, fork, create me a new process, exec, replace what that process is doing. So that's important to know the distinction because for many things, the parent-child process relationship is important. So let's get into some of the details. If you want to follow along in terms of seeing how this is implemented in code, I left these bullet points here so you can go explore for yourself. So we're not going to go look at these things today, but if you want to take a screenshot online or take a photo here to go follow that later, this is there for kind of self-directed learning. So we're going to start out with a bit of trivia, because this will show up in the kind of the design of Nix Develop, which is that Nix Shell and Nix Develop are primarily designed for debugging builds. They're not kind of designed from the ground up to be developer environments. And you can see that DNA because they both recreate the build environment of a derivation. And so you can kind of prove this to yourself by running build phase inside of a Nix Develop dev shell. So build phase is a script that is one of the many phases that happens during a Nix build. And so if you run that inside of Nix Develop, you'll see that it's defined to something. It probably won't work because you haven't run any of the preceding steps, but it is there. And so you can see that this is the Flocks repository. I just did a Nix Develop there. And there's this huge error message because we haven't run any of the previous phases, but that shows you that build phase is defined there. Okay, so the first steps that happen when you run Nix Develop is that it kind of figures out what derivation you're talking about. So we're not going to get into those details, but say that you run Nix Develop foo, it finds the derivation that corresponds to foo. All right, so once you have that derivation, we're actually going to transform it. That's kind of the first meaty step in Nix Develop. So every derivation has a builder and a set of arguments to that builder. And so normally this is like some script. Maybe you've defined it yourself. Maybe it's from one of the Nix packages helpers, that kind of thing. But what we're going to do is we're going to replace those arguments with this other script called getenv. And so what this does is it basically exfiltrates the environment that would be present during that build. And so what it does when you build this derivation is it produces this JSON object that has a top-level bash functions key and a variables key. And inside of that, there are keys for every function that was defined, every environment variable that was defined, and then also for variables, it tells you what type it is. So this can be exported, it could be an array, it could be associative, blah, 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 all that kind of stuff. And so it does this line by line, which is kind of cursed because JSON, notably not a line-oriented data structure, it is tree-structured. So if we look at the script, I've cut out a bunch to simplify it and give you kind of a high-level skeleton view. First thing it does is run setup from standard div. And basically what this does is it populates path, CMake, prefix, path, stuff like that. Basically all the stuff that makes your dependencies available in your dev shell. And then the next thing it does is it dumps out all the variables and functions, and then it will run this dump env script. And this is what constructs that JSON object line by line. Again, cursed because this is not a line-oriented data type. And so this is where we started getting into like the gnarly stuff, because this is kind of a simplified snippet from the part that is basically parsing bash function definitions in bash. Yeah, this is the tip of the iceberg. Yeah, so I mean, you can see we're doing like regular expression matches where for printf, like there's the colon for the JSON separator, which brings us to our first encounter with hell. You can't see this because it is too bright in here, but that's hell. And so we're going to see a bunch of depictions from Dante's Inferno. This is one of them. It gets worse if you look at the part that kind of parses the variables. Don't read this, but basically you can just see that it's more and the previous thing was ugly, so more ugly, bad. We're doing this whole like exported var array associative and I guess unknown. I'm not sure what an unknown variable type would be in Bash, but yeah, this is where we're kind of switching on those types so that we can enumerate them. Also hell. I like this one because it looks like Satan is pouting, which I would also do. If you want to see the full JSON representation from your Nix Develop shell, you can run nix print devenv with the JSON flag, and you'll see, this thing that I showed earlier. So once you have that JSON, what you're going to do is parse it into a build environment struct in the C++ code, which then translates it back to Bash. So once you have that, you're going to apply some transformations to that environment to kind of build up this RC script. One of the things you'll do is you'll append this line that says eval shell hook. So if you define a dev shell with like make shell or something like that, and you define a shell hook, this gets appended to the end of this whole script so that you can customize things after you've done your kind of generic Nix Develop setup. So we're going to dig into kind of these details next. Once you have that script, what you do next and how you transform it depends on how you're invoking Nix Develop. So are you running just a command with it, so with a -c flag or -- command, or are you putting yourself into an interactive shell? If it's just a command, you're going to do all this stuff to make the script, and at the end, you're just going to exec whatever the command was. So you're going to set up the environment and then just run a command with that environment present. If it's interactive, this is very important. You're going to prepend this line that says to source the user's bash RC. So that's very important because you want all of the Nix setup stuff to basically run last. Because if you do all your setup and then run the user's bash RC, that could set path to like a fixed value, or it could add something to path that puts something in the user system before all the Nix stuff. And at that point, you've kind of ruined things because the whole point of Nix Develop is to make sure that somebody running that gets exactly the same environment, exactly the same dependencies every single time. And so, again, you put the bash RC script first so that Nix basically gets the final say in what the environment looks like. Then at the very end, this is where we actually run or put you into the bash shell. So you exec bash with this RC file flag pointed at this script that we're building. And so what this does is it basically says, rather than running the user's bash RC, run this other script. You will still run the user's bash RC script because we have, like I said, just prepended that to the thing that we're building. So this brings me to kind of one of my pet peeves, which is that people who are kind of like new to Nix will like discover Nix Develop, and they're like, well, what if I want to use Z shell? Or what if I'm enlightened and want to use fish? And some people will say, well, just exec that shell after you run Nix Develop. So Nix Develop -c, that shell, which, as I've just explained, is wrong because once you exec that shell, it will run that shell's RC scripts, which is notably after you've just done all of your Nix stuff. So that doesn't put you in the same environment as somebody who is just using bash. So that is broken. Don't do that. And don't recommend it. So now we get into some of the details that this script actually does. One of the first things that it does is it sets path and XCG data drs, but it doesn't just obliterate their previous contents. For these two variables specifically, it will prepend to them because essentially if you obliterate their current contents, nothing will work after that. So don't do that. Another thing that it does is basically points anything that looks like a variable defining the location of a temp directory to a new temp directory. And so if you do Nix Develop and you echo temp, for example, you'll get something like nix-shell.some gibberish. That is your new temporary directory while you're in Nix Develop. This is fun to discover if you don't know that it exists. And you're wondering, like, why the hell are my files not where they're supposed to be? Another thing that it does is it will rewrite the outputs of that derivation that you transformed. So for instance, you normally have this variable out that kind of defines where you're going to put the output of your derivation. And normally this points at the Nix store. But if you're doing development, you don't want to accidentally, move something into out and just write gibberish to the Nix store. That would be bad. And so what the script does as we're building it is it rewrites those to point to somewhere else. And this happens to be basically in an outputs directory under your current directory. So for instance, if I go into the Flocks repo, Nix Develop, and then echo what out points to now, it is basically, that's where my repo ends, outputs/out. So this is actually pretty helpful if you're debugging a build. You can run one of your phases or whatever and go see what it actually put in there. Another interesting thing is that it involves itself with the garbage collection process. So it would be pretty shitty if you were in your development shell and one of your dependencies was garbage collected out from under you. You probably don't expect that to happen. So we have to make sure that all of our dependencies are in the right place, make sure that they stick around while we're in that shell. We also want to make sure that the script that we used to get into the shell doesn't get garbage collected. So the script sets this Nix GC root variable to the store path of the script. And I submitted a whole second talk on the garbage collector. There is all kinds of stuff in there, including, yeah, there's a whole server in there that listens on a socket for anything. Yeah, well, why? Correct question. So we can talk about that later if somebody wants to know any cursed things about that. But one of the things that it does is it scans /proc on Linux, looking for anything that's currently running that has store paths, either open as a file descriptor or something like that. And so this function is find runtime roots if you want to go peer into the abyss. And so if you want to see what the actual script looks like, you can run this nix print devenv command. So previously we saw that with the JSON flag. This, without the flag, gives you just the script itself. Another way to do this is to build the dev shell output of a flake and just go look at what its contents are. So now we get into Flocks activate. So we've prepared that script with Nix Develop. You exec bash with this RC file. That's honestly, having worked on Flocks activate, refreshingly simple. Flocks activate has a different set of goals. So we want the same reproducibility as Nix Develop, but we also want to support different shells. Currently we support bash, Z shell, fish, and TC shell. We also support 2 different closures. We support like a develop and runtime mode. So this is kind of similar to Nix Develop versus Nix Shell, where this runtime mode kind of just puts stuff in path. We also want faster activation. So with Nix Develop, currently you evaluate the derivation that puts you into that shell. And even if that is like cached in some way, it's still not super fast. So for the Flocks dev shell, it is several seconds, which is not excellent. But we'll get to that in a minute. Additionally, Flocks activate supports this idea of like layered activations. So you can activate multiple environments at a time. So this is cool for context switching. We also want to share some resources between activations. So say that you activate an environment in multiple tabs. There are some things that we want shared between those, namely services. And another thing we want to support there is when you close those tabs, we want those services to be automatically shut down. So finally, this is just kind of a nitpicky detail, but we want your path to be kind of tidy. So if you do a Nix Develop and then you look at path, you have a store path in there for every dependency that has like a bin directory, whereas with Flocks Activate, you have one directory. So this is the high-level flow for Flocks Activate. So there's a lot more going on here, so we're not going to be able to get into the same amount of detail. But contrast that with Nix Develop, Flocks Activate. Nix Develop, Flocks Activate. It's more complicated. At its core, it's doing something very similar, where you have your user shell, you fork off the Flux process, and then we exec bash. But this isn't the shell that we're going to put you into. Since we support multiple shells, we kind of separate the activation process into the shell-agnostic parts and then the shell-specific parts. So for the shell-agnostic parts, we use bash here. And this uses a tool called Flux Activations, which we'll get into in a little bit. That talks to some state that we keep around. This is basically just stored as like JSON on your file system somewhere. We also have this Flux Watchdog process, which is kind of doing this monitoring to see how many tabs you have open with this environment in it, so we know when to shut things down. This used to be called Klaus, after one of our coworkers' French bulldogs. But that was too much whimsy for some people. So RIP Klaus, lost but not forgotten. This also is responsible for shutting down your services. Let's get into it. One of the primary ways that this is completely different from Nix Develop is that everything is built ahead of time. So when you build a Flux environment, everything that's necessary to run your dev shell is basically already there. This is eagerly built when you run Flux commands that modify the environment, or if you manually edit your config file. We call it a manifest. This is just a TOML file. We'll see in a second. If you make manual edits to that, rather than going through the Flux edit command, we'll detect that and then rebuild next time you run any Flux command that needs it. So if you want to see what this looks like, we have this .flux directory. Inside of it, there is this manifest.toml. And then in this run directory, we have these two symlinks. People are moving the projector up there. We have these two symlinks, and these point to basically our two different closures. So this .dev points to the kind of Nix Develop style dev shell, and then run is the more Nix space shell. I don't know how you're supposed to say that in a more elegant way other than Nix space shell and Nix dash shell. Somebody inform me at some point. Okay, so if we follow those symlinks into the store, we see this. This is the contents of your environment. And so another primary way that this is different is that we basically recursively merge your entire closure into this directory. So for instance, this bin directory is the merged bin directories of the entire closure. Same thing for lib, share, include, et cetera. And then there's a few other things that we kind of sprinkle in here for our own purposes, namely this activate script, which is kind of, somebody's having fun next door. This activate script, and then some kind of like helper scripts to go along with it. So this is what gets run when we kick off Flux Activate. So when I talk about immediate activation, what do I actually mean? So basically what I'm showing here is a comparison between running the true command by absolute paths, so that there's no shenanigans about running shell built-ins. So first with Flux Activate, and this is in fish, and that takes 50 milliseconds to basically put me in the shell, run the command, and then get back out. So doing that without activation, just running it in my normal fish shell, takes 16 milliseconds. So that's a difference of 40 milliseconds for Flux Activate, much faster than a few seconds, right? So that's pretty nice, and one of my favorite features. And this is what basically building things ahead of time allows you to do. So like I said, there's no evaluation on the way to activation, and depending on what your dot files look like, the rate limiting step can be either Flux or not Flux, depending on what your dot files look like. And so 40 milliseconds is kind of quick enough. It's not zero, but there's low-hanging fruit there that we can trim some time off of that if we feel like it's a priority. And so I figured that all out kind of by writing a profiler, as you do. So I wrote this with BPF trace to track fork and exec and exits. And it's broken in various ways, so it's not super useful at the moment. But basically what this does is it spits out mermaid syntax for Gantt charts. And that looks like this. And so one of the weird limitations of mermaid syntax is that the smallest possible time that you can represent is 1 millisecond. So all these blocks look like the same amount of time, and in reality, they are very much not. So essentially what you're seeing here is we start Flux activate. This is doing something in fish. This is actually running activation with the RC file that we've prepared. This is kicking off a background check to see if you have like upgrades available for your packages. This is the watchdog getting spawned and waiting for things to exit. But yeah, so that was pretty cool. Another thing that's kind of different about our architecture is that we have two different shell hooks, or two different sets of shell hooks. So we have, in our manifest, we have this hook section, and the only thing in here is called onActivate at the moment. So this runs in the bash shell, in the kind of shell agnostic part. Then we have this profile section that has one entry for each shell, and then a common entry that will run in all of them. And this is run in, basically, this gets injected into the RC script for your user shell. And so this allows you to set things like aliases in your shell, so that's pretty handy. We also have this idea of starting versus attaching to an activation. Starting an activation basically does the whole thing, and then attaching to it will kind of replay diffs of the environment. And so basically what happens during activation is we kind of take snapshots of the environment at various points, and then we will kind of compare those to compute these diffs. And so we do that because you can tell users all you want that, oh, this should be idempotent because we might run it more than one time. Okay. Same thing with this. You can tell users all day this is idempotent, or it should be idempotent, so write it a certain way, and they won't. So basically, we want to make sure that we can run things as few times as possible. One way to do that is to kind of just compute their effects, which for you functional programming nerds is a thing that you care a lot about. But yeah, so we take those snapshots and we can apply them. That's what kind of attach means. So if we come back to our diagram, the next thing I think we're going to look at is, yeah, this watchdog. So like I said, we want to keep track of essentially how many instances of an environment are active right now. So basically, how many shells do you have this thing running in? And that is the job of Flux Watchdog. Like I said, activation state, this is kind of where we store all those snapshots of the environment and their diffs. We also keep some information about, I think this is also where we keep the socket for being able to talk to your services. Another thing that we have to keep in mind here for our architecture is that layering is a thing that we explicitly support. And so you need to keep track of which other environments have been activated. And so that adds kind of a significant amount of complexity because you always need to make sure that environments get added to the right variable, or directories get added to the right variables, that kind of thing. So as I mentioned before, that activate script is written in bash, and that is kind of the shell agnostic part of activation. And then we defer all the shell specific parts to the very end in the kind of shell specific RC files. One of the things that the activation script does is it sets Flux imters, which is how we keep track of which other environments have been activated in this shell. And then it sets path, man path, stuff like that. One of the tricky parts of doing this is that if you support multiple shells, you need to kind of ensure that they have consistent behavior. And if you need to support an arbitrary number of shells, they each have their own dialect with different quoting rules, array support, rules for source and eval, etc. It gets pretty gnarly. So that's a big, difficult problem, which brings us back to hell. Yes. So that brings us to the abyss. So this is a Notion page that I created internally with bangers like Python. And that command, it does not do what you think it does. Notably, this whole shell idiosyncrasies section. So let's get into that. Bash and Z shell support hieroglyphics. I debated on asking whether anybody in the audience understood what this means, like these two invocations, and then I thought, anybody that raises their hand has probably experienced enough trauma that let's not out them like that. You basically just quote everything possible until it goes wrong, because if you do it the other way around, you'll just go and you'll run into the it goes wrong part immediately. So it's just kind of defensive quoting of everything. TC shell has no equivalent of this particular hieroglyphic, which basically all that does is it defaults to an empty string if this foo variable is unset or null, which is a simple way of saying, if it has a value, gimme. If it doesn't have a value, empty string. So TC shell has no real equivalent for that. TC shell, so when you do these kind of create an RC script things, one of the things you end up doing a lot is evaling the output of another command. Maybe because that other command has built up some shell syntax for you, or shell code for you. If you want to leave yourself notes about what it has generated, one idea would be to emit comment lines. Don't do that in TC shell. Oftentimes, it won't treat it as a comment character, in which case you'll get something that looks like this, which is really confusing if you don't know that this happens. Other times, it will say, OK, cool, that's a comment character, but so is literally everything else that comes after this, regardless of whether there's a semicolon or a new line. So just don't do that. TC shell sometimes just won't let you quote something. So this one, like, kind of makes sense, and like you're already inside double quotes, so like other double quotes won't work. So TC shell has this thing called modifiers that you can put after the variable. So in this case, it's colon and a lowercase q, and that basically tells TC shell, I can't write double quotes here, but do the quoting for me anyway. Just kidding, that doesn't work in backticks like we needed somewhere. I don't think I showed it. Whatever, right here, yeah, right here. So you can't use colon Q right here, which is kind of like exactly where you needed it. So new versions of TC shell, as of 2021, have a capital Q, right? Yeah, so like I said, that's only new versions of TC shell. And so if you're using TC shell, I don't know how frequently you're updating that anyway, so I don't know if this is like a thing that you even know about. Hell. We're back to hell. Okay, TC shell doesn't have an internal field separator variable, so like if you have a path variable and you want to separate it into an array, you can't do that. Without doing other stuff that's just like not natively supported. Ask me how I know. Z shell, we're going to stop picking on TC shell now. Z shell has both fpath and fpath. So these are basically path, but instead of for like executables, it's for shell functions. And so they actually both refer to the same quantity. They're kind of just different representations. So lowercase fpath is a space-separated array. It's like a shell array. And uppercase fpath looks basically like path, so it's colon-separated. If you set lowercase fpath, you're all good. If you set uppercase fpath, basically Z shell says, oh, you've set it to something? That means you know exactly what's supposed to be in there, and I won't load anything else. So basically, when you go to create a new Z shell subshell, you'll lose all of the default ones from your system. Cool. Fish. I don't really find these a problem, but I figured I just had to include a slide on fish, so I wasn't like the most biased. So everything in fish is essentially a list or an array. That's what they call arrays. And so if you quote path, you get a different thing from if you don't quote path. Basically, this one is a space-separated array. This one looks like what you expect path to look like, colon separated. Fish prompt is a function. It is not the format string itself. It is a function that when executed produces the format string, which is like kind of neat in the sense that you can execute it, save its output, and then wrap something around that. So that's nifty if you want to like put something in front of the shell prompt or something like that. Startup files. So yeah, man, this is so validating to hear everybody groaning at the same time. Z-Shell has a lot. So really it has 10, but 2 of them are not startup files because it's like Z logout. So you have under both Etsy and the home directory, you have Z-Shell RC, Z-Shell env, and Z profile, and Z login. So you have a copy of those under Etsy and the home directory, and then you have the same thing for login versus logout. Different ones of those get run depending on whether you are a login shell or not, or an interactive shell or not. Apparently macOS doesn't really have a concept of a login shell, but it like fakes like it does. So basically everything is a login shell or something like that. I don't know. I learned that at one point and then intentionally forgot. Bash is kind of similar in the sense that there's like profile, bash RC. Those get loaded in different contexts. Fish, my beloved, basically has config.fish. And there's one like under Etsy. Love it. I didn't count for TC shell. So I said that I'm an engineer at Phlox. My other title, this is on LinkedIn as well, is the official Phlox meme lord. We're not done. Yeah, so fish, like I said, objectively the best shell. So all that stuff is super complicated. And just based on the diagram, you can see that it's complicated, much more complicated than Nix Develop. So I wrote a debugger. So this is written with the Ratatouille crate in Rust, which is relatively nice to work with. One of the nice things about this is that you can use it to kind of explore environment variables. So over here you have a list of variables, and then this is kind of the view. So the default is just viewing it as a raw string. And another thing you can do is split it so that you can kind of peek at these individually. So that's nice if you're like, wow, my brain kind of glazes over when I see that. What if I wanted to see it in a way that I could actually interpret? Wow, that's cool. Okay, that's first in path. Oh, I forgot. This also has the ability to walk a stack trace in your shell. Shells have stack traces. Did you know that? You do now. It's also kind of broken. You can see that the screen is like kind of corrupted here. I don't know what that's about. But this is kind of cool because you can go see like, okay, I was in that file on this line, this file on that line, blah, 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 blah. So it's cool when it works. Okay, back to Phlox Activate. So I mentioned that this is complicated to do consistently across many different shells. So the big difficult problem, doing that all consistently, the tractable problem is to implement the business logic in as few languages as possible. So we have Bash for the shell agnostic parts, and then we have this other tool, Phlox Activations, where we need to do something kind of consistently across multiple shells. And the nice thing about that is that problem kind of reduces to emitting variable exports or source this other file. And that's pretty consistent across shells. There's different syntax, but the semantics are pretty similar. So like I said, this is that Phlox Activations tool. We have a couple of functions in here. Basically, this acts as as closely to a pure function as possible, intentionally, so that it's kind of easier to debug. So here we have basically set environment directories. You tell it which shell you want to emit syntax for. This one is saying basically fix up path and man path. We don't have time for this, but man path has its own monster of where you put colons. Oh boy. So if you want to debug something that's happening in that activation script, you can just run Flock's activations directly. So for instance, if I want to see what it's going to do for path and man path, I just say, OK, tell me about bash. Pretend that that's an environment directory that I already have activated. Pretend like that's what path already looks like. Pretend that man path is empty. And then it just prints out this because it's going to source that output in our bash shell. So that's really nice for being able to kind of divide and conquer. OK, back to activation. What was I about to talk about? Start or attach, yeah. So this is kind of going back to this activation state. We have, as I mentioned, we have these two different hooks. Hook.onActivate might do something expensive, so we don't want to do that every time you activate. So we take snapshots along the way, create diffs of those snapshots so that we can basically just apply them later. Flocks has built-in support for services. So this is like a database, web server, whatever. You define this in your manifest, basically just like a command. The thing that's responsible for shutting them down is that watchdog that I mentioned earlier. And this is also hell. So it turns out to be surprisingly difficult to find out when a process has terminated without race conditions, and actually not just race conditions, but also actually finding out. So if you just Google this, or whatever your search engine of choice is, you'll see recommendations for like kill-0, which is wrong, because it doesn't really differentiate between running processes and zombies. So if you're waiting for everything to be shut down before you run your cleanup stuff, you'll just wait forever because something hasn't cleaned up a zombie. So that doesn't work. Also, this relies on polling, which is a race condition. Something could reuse a PID between two invocations of kill-0. Tail-F is another thing that you'll see recommended, which often just uses kill-0 under the hood and has the same problems, so that doesn't work. On Linux, you can read /proc. That is just a race condition and isn't available on macOS, obviously. So what do? You find yourself in hell again. So the solution is you basically have to use platform-specific APIs. So Linux has this thing called prctl, which is like...
I'm really sorry. Here, over here, you've got 5 minutes left.
Okay.
Just
yeah, there's a timer.
4 questions usually.
Yeah, we're almost done. We're almost done. prctl is process control. You can set something called a child subreaper, which is basically rather than a process being orphaned and like reparented to like init or something like that, say no, reparent it to me, even if I'm not its direct parent. You can also say when something is terminated, send a signal to me. So that's kind of how you do that on Linux. On macOS, you have KQ, which is used for all kinds of things, but one of the things you can use it for is you can subscribe to exit notifications. And that kind of corresponds to just polling a file descriptor. And there's no race condition with that poll because the events are written to that file descriptor, so you basically won't lose them. Finally, you prepare that RC file. This looks kind of similar to the Nix Develop case, but we don't have time to go into like all the specific details. I mentioned that Z Shell has 1 million startup files, which makes it very annoying. But that's where we'll leave things. Thank you for your attention. Thank you for validating me and my pain. If you want to find out more, you can reach me at these links. You can find Flocks up there. Thank you for your attention.
Thank you, Zach, for the great talk. Any questions? Let's start over here.
The schedule, I couldn't find the presentation. Will it be available later on?
It will be available. I just haven't uploaded it.
So I was wondering, like for normal things, there are some things like plugins to let you use fish or whatever in the shell. Do you have like a preferred one out of those?
Do I have preferred plugins for
for Nix
fish?
Develop for being able to use fish as your shell? Like there's Nix anywhere?
I use Home Manager. I don't actually use any plugins for Fish, actually.
I mean like to use Fish in Nix Develop.
Oh, I don't.
Okay.
For those exact reasons that I mentioned, it's kind of broken.
Hey, thanks for the great talk. I was kind of curious on two things. One, if there was Flock's support for Devenv, such that you can like just CD in, and the other one was the Devenv does have like a use Nix and use Flakes, and you could still use Fish. I was kind of curious if you had any idea on the differences between that and Flock's.
So I don't use Devenv, so I don't know that I can speak to a lot of the details. I do know that it causes some breakage with Flocks in some cases, because I think one of the ways that Devenv works is it kind of takes environment snapshots rather than like running a script every single time, something like that. I could be wrong about that because I don't use it, but that's caused us some problems in the past. But we have an open issue about this on GitHub to have better support for it, so it's something that we're aware of.
Cool, thanks.
Any more questions? No? Oh.
Might we see more shells later on in Flocks, apart from those that are currently supported?
Sorry, could you ask that again? I couldn't hear.
Might we see more shells apart from the 4 that are currently supported, like maybe new shell support if it eventually stabilizes?
It's something that we've heard about. Like, people have asked us about new shell specifically. I don't know, like, on an infinite timescale, yes, we will support other shells, but I don't know where that lands on the roadmap. Because supporting activation, like Flocks Activate, turns out to be kind of one of our main maintenance burdens. So adding a new one, especially one that's not like super duper widespread, is kind of tough. So even Fish is this pains me to say, but is way less popular than either Bash or Z Shell. Those two are kind of like almost 50-50 in terms of usage from what I've seen. Fish is like a few %. I do what I can, but I can't do that much.
All right, thank you. Any more questions? But we are almost out of time. One more? No? Oh, yeah, sorry, no, we're not going to make that. Then thank you for the great talk. Let's give a round of applause for Zach. Thank you. Then we're going to be back in 10 minutes for the next talk. Hope to see you all there.
Okay, everyone, let's get ready for our next talk. So we have Kenji and Kubasa. Their talk is titled "The Road Towards a NixOS UI." Wait, this is Clan, right?
Yeah, it's from the Clan project.
It's about Clan. Okay, so let's welcome our speakers.
Yeah, welcome. We want to talk about our roads towards building a NixOS UI and where we started. So let's look back at what we had before trying to build the UI. We were thinking about how can we make deployments easier for users, and we had the question, what keeps people from running their own services? And there are a lot of things that users need to think about and manage if they want to actually run their own services. Like a lot. You need to know how to set up, how to bootstrap the machines, how to manage the backups, collect the health metrics if they actually want to know what's going on in their running systems. They will need to make their computer reachable. And you might not want to have it publicly reachable, so you want to configure a VPN, or even multiple VPNs if one VPN fails. And it goes on and on. And people might not know what they are missing, what they need to know to start. So what we came up with is an opinionated deployment framework. There are already a lot of deployment frameworks that are out there, but you need to know exactly what you want to do in order to start using them. And that is the problem. How to start, what to choose. It's kind of the unknown unknowns for most users, at least. And our solution for that is just guidance and defaults. We have for a lot of things, secret deployment, secret generation. We have one default, but we try to be accommodating for people so that things can be modular still. And the tools are often a little bit split in the community. So we have one CLI interface to utilize everything, to install machines, to update machines, to manage backups, to flash a new Flash installer with your SSIH keys so that you can easily boot into the installer and install your machines to have a more convenient interface. And this is the point where we started at, to build towards the UI, to make it even easier for more people, to try to, maybe you can figure out how to use it with a CLI, but you have coworkers or you have friends that you co-host stuff with that may be easier to just click a button to deploy or update the machine. Or just they can tell you if something is wrong because of the health metrics. So we have a couple of components that make bootstrapping easier and that are, we think, vital to bootstrap a good UI for NixOS specifically. And one of the components is a secret management system that is declarative. Because often services need their secrets before actually being deployed. But you need to then generate them manually, or you need to set them up somehow, like generate a public-private SSH key pair. And for that, we have a declarative system to manage the secrets. So modules can opt into their own secret usage before being deployed. That solves a fundamental bootstrapping problem that is kind of batteries included for the module. And it enables automatic service deployments if it doesn't need a user interaction, for example, like a user password that is being prompted for. It also enables like for really easy key rotation, because we have the generator, we have the service hooked up, and for now we have it in a CLI, but we have an API that the UI is using. So key rotation can be one click, and it's using the same interface as our CLI for rotating the secrets, for example, a public-private key pair for SSH, or for like your WireGuard connection, a new key pair. And you can test the secrets also. So you can have a testing service boot up with a Disco VM, and in the test you could generate your secrets automatically and see if everything's working correctly. And we now have YubiKey support, so yeah, you don't need to have your keys on the device actually. This is how a service would opt into its own secrets being generated. It's like one of the most simple solutions, because there's not like much going on here. So I will explain what is actually going on here. We have the generator, ClanVAS generators, for the Miniflux service, which is an RSS reader. And if you want to hook it up with KaniDM, for example, you want to have some key material generated. And this can be done automatically. And here we use files.password to signal to the service that out of the generator, a file called password should be generated. And by default, the file is a secret, so it is automatically encrypted with your H key and can be then deployed by the deployment system through ClanVAS update or Clan Machines install. Then the script will be run inside an environment that is suitable for generating passwords and automatically encrypted. And modules can then opt into the configuration by the path you see down there. And we can also ask the user directly in the module for their input. So here, in this case, there's a shortcut for like file and copying what is coming out of the file in the prompt. So we can actually say just like, for Adwin, we want the key to be persisted from the generator. And in this case, the user is then asked in the CLI to just put in their Adwin key. And this also works then in a UI. So it is like a flexible way to bootstrap machines, even though you might need to have user input. And you can have it in a UI as well. The other part that we use for improving NixOS setup through machines is our service layer, which we call Clan services. It's a little bit different than normal services because they are on top. They know about multiple machines. No. Ah. Okay. Thank you. All right. So, for example, in the work backup service, if we know that the server should have the role server, like a machine, and another machine is a client inside of the service, we can tell the inside of the module that the backups from the client should be sent to the server. And this way we can give good defaults through role-based assignments inside of a service, like a multi-machine assignment. And let's look at how that actually would look like in Nix. So this is an example for a VPN configuration. Here we have an instance, so you can have multiple instances. And we have the server here, which has the role controller. And the controller lets the other machines into the network. And all the other machines are just added as a peer. So we have a tag system that you can use. You can assign machines to tags, and there's some pre-computed tags to make it easier. For example, you have the all machines tag, you have the NixOS tag, you have the macOS tag, or Devenv tag. So you can have just your services that only work on NixOS also automatically just imported on the NixOS machines. And the good thing about this service here, this is JSON compatible. That means that we can we can add and remove machines to services through a UI, but it's still Nix compatible with your usual deployment systems. So we call the layer that is JSON compatible our inventory, and one part are the services inside there. The other part is this tag system and the machine system. They kind of work in concert to allow you to manage those things very flexibly. And yeah, so you can have a good overview of which part of the machine is inside your network. So let's look at how we use the different tools then to install a new machine, for example, that we either build or that we connected from the community that many people here already would know. So an example here would be the NixOS Factor project with the NixOS Factor modules project. The Disco, we enhanced it with a little bit, just a little abstraction on top, which we call Disco templates. Then we have our vars, which we talked about previously, and then we use NixOS Anywhere to install the machine. And the NixOS Factor report is something that can be used on any NixOS, any Linux machine that can be kexec'd into, so we can generate this report remotely on a machine. If you just like on a button press or on a CLI, we get a report. And this is actually very, very powerful here. This report lets us set a system, so you don't need to set a system anymore. It allows us to correctly enable the optimizations for like KVM. It can load corresponding modules for your maybe laptop or other drivers for like energy efficiency. It can be regenerated, so if you switch something out in your system or if your provider just has different hardware suddenly, you can click a button again, this can be regenerated, and we can auto-load the correct modules with NixOS Factor modules again. And there's theoretically no need anymore for the NixOS hardware repository. Not everything that NixOS hardware has is in there yet, but the goal is that nobody has to figure out after 2 years of using the machine, suddenly, oh yeah, I need to import something from this repository because I have a laptop that has the specific kernel version of this. Like this is, we want to make this automatic, and this works with most of the machines already, with the frameworks and all the machines that are not niche. This already works nicely. And as a bonus, we can assert if we have certain services that need specific hardware. So we can, here in the code you see, we can actually assert on specific vendor requirements or just maybe free space that you have, or like a disk controller. So you can be very specific in what you actually require in hardware for your modules. And then we fill out also the template from Disco directly from the Factor report, because the report has the disks inside of there. We can, in the CLI, we can give like a drop-down menu. In the UI, we can give a drop-down menu. So you don't really, you just click, and then outside of the Disco template, a disco.nix is then generated that has your preferred formatting. But we provide some very simple default formats that should work for most people. This is flexible. You can choose your own abstract Disco templates, and it can be filled in by the UI then. So in concert, to show everything in one, we first generate a hardware report. We use the hardware report to load certain modules and fill out a Disco template. We generate the vars, which we haven't talked about in this case yet. For example, SSH key pairs are generated there and encrypted. But also, there's no need to have your state version anymore in your config, because it's not really a config part. Vars also support public files that are injected into the configuration. And then we can generate the public part, the state version, and you don't need to care about the state version anymore. And then everything is installed, as you may already know with NixOS Anywhere. This should be very familiar to you. And now let's take a look at the UI that we have so far.
Well, let's make a live demo and load up my clan. So I load up the clan app and notice that we can either start building our own clan from scratch or select an existing one. In this case, I select mine, and we'll drop into like a bunch of machines, right? And they're coupled up together. So yeah, I wanna sort them a bit. So I wanna have these two over here, these two, let's put them here, and this one here. So what are these machines? Well, these are the macOS machines of my parents. I can manage them more or less. So at least I can join them into my Mesh VPN 0 tier. This machine over here is just a normal heads machine that I use to like host my email server with simple NixOS email. And this here actually is just an old refurbished ThinkPad laptop that I use as my server, which I use to host Matrix. You can see here some services. So it uses like a DNS service, like a dynamic DNS service, to regularly update the IP address of the domain name. I use it for Matrix, and just to be sure, so if it the DNS service breaks or something, I can still SSH into it over Tor. And this right here is the machine I'm currently doing the presentation on. And well, now I want to create a sixth machine, right? And to create a new machine, and this machine is supposed to, I don't know, share some files and services with my family. So I will call it KinHub. It's a NixOS machine, and let's say I also want to give it a tag. So let's give it the family tag. All right, so it's created, and now, all right, now we have 3 machines in the family tag. Now what I want to do, okay, I want to add some monitoring to it, okay? I want to see if the disk is full and whatever, if it's offline. So now I can click on this Services tab to add a service and look for monitoring. And now I can select machines I want to install the service to. In this case, I could select, for example, the tag on all machines that have the family tag, or just KinHub, for example. And I want to add the service. So the next up would be, all right, cool, we have this. So now let's install a machine, right? So over here, we have like a handy-dandy little booted up NixOS virtual machine that I want to install. So now I can choose between, okay, if I have a physical machine, I could flash an installer. In this case, I just want to do a remote installation. And let me type up the IP address. And we can test the connection. Okay, we could connect. And now it's the hardware generation step, right? So this will, if I click now on the button, this will generate the hardware report we talked about earlier. And now it got generated, put into my Git repository. If I click next, we'll see this list of disk paths. This disk path list is straight, like gets ripped from this hardware report we just generated. And it will be used to automatically fill out the Disco template. In this case, a very simple ext4 100% partition. But in the future, of course, we'll add ZFS and more complicated partitioning schemes. So as you could see, now it queried, like it looked at the machine, looked at what services it had, and then looked what generators, like what secret generators it needed for these for this machine. And it saw, oh well, it has like an admin module attached to it, and that configures like a root user, and it pre-generated, for example, a root user password for me. So now I go to installing the machine. This will take a bit, so I will give over to to Kenji.
This is still in a very early phase, but we wanted to show it already because we're excited about it. We think you can already maybe see where we want to go with it. And we would show you first what our roadmap is for the near future. So we want to make sure that state migration between machines is possible, like from one machine to another. Like if you need to migrate from Hetzner to somewhere else, for example. The monitoring and health checks, we want to integrate them in a similar way as the vars and the backup modules we already have, but which we didn't talk about here. But basically that your service modules can export meta information about what health checks are important for this service, and they can then automatically be added to the export of the machine. So you know which is the important thing to look out for on this machine because this service is running. Then what we are interested in as well is the service layer is pretty flexible and it is self-contained. So we would like to be able to have people to share it. So we are thinking of the name is work in progress, but we call it currently Clan Hub, but something that people can share their services on that doesn't need to rely on a central repository, and also that doesn't need to rely on a single kind of a single kind of failure, maybe as failure mode. Yeah, we want to improve the macOS support, and user management is currently very one-dimensional. You can have multiple administrators currently for multiple users on the machines, but it's not much more granular than that. And we want to be able to have proper user support integrated into the system, which we don't really have yet. So do we want to see if it's installed?
So let's see. Let's see if it's already installed. So okay, it's still formatting, so it's not yet installed.
We can check back later, but what we are interested in is your feedback. Like what you've seen here so far, we would like maybe you can join us on our Matrix channel, or maybe check out our Git repository. We have office hours every week. And we would really want to have people try it out to see where it fits for them, because this is really a design phase still, and we are not currently using it for ourselves yet, the UI, but we are using the CLI currently, and we're very happy with it. So we hope we can be happy with the UI as well in the future. Thank you.
So I'm afraid that time is kind of up. Maybe we can.
Yeah.
Maybe one question, but
yeah.
Then maybe that seems a bit unfair. But I don't know. It's up to you.
Yeah,
only if you can quickly respond and quickly ask.
We can do a question. Otherwise, find us where the hammers are in the halls, and we can answer your questions there.
Okay, let's just do that. Okay, let's thank our speakers.
Thank you.
All right, so let's continue with our next talk. It is titled, Is NixOS Ready for the CRA? Let's welcome Lukas.
Thank you very much for the introduction. Oh, that's the wrong screen. There we go. Okay, yes, my name is Lukas Bayerlieb. I work as a software engineer at Cyberus Technology, mostly with virtualization. I'm very happy and lucky to do a lot of Nix at work. And yeah, sometimes the team lead comes around and said, can you stop the engineering and maybe take a look at this CRA thing? And then I did. And then we would like a CRA talk at the NixCon. You know the most, why don't you do the talk? And so here we are. Okay, first of all, I want to ask you, who has heard of the CRA? So, okay, that's the great majority. And if I ask you to just summarize it in a sentence, who has any idea what it's roughly about? Okay. That's quite a bit less. And who had also the pleasure to look into it a bit more in detail? And all right. All right. Then I hope you can take something away from my explanations here. From my perspective, it feels like the CRA is everywhere. Brought some examples. In March, we were on the Embedded World conference. And basically every banner said, oh, this product is ready for the CRA, or buy our platform, it's CRA ready. Last week was the Open Source Summit Europe in Amsterdam, and there were quite a lot of talks about the CRA and even a panel discussion. And also if you look over at Ubuntu and the Canonical guys, there's quite some presence of the CRA on their blog. And Yeah, so CRA, Cyber Resilience Act, I think it was on the slide, but I didn't mention the full name. Most of you heard of it. Anyways, short introduction. Cyber Resilience Act is legislation from the EU concerning cyber security. And you might ask yourself the questions, why does the EU care about software and security? And if you think about the bigger picture, it affects a lot of things. The EU economy can be affected if there are outages due to cybersecurity. The democracy might also be a danger. Think about voting and misinformation. And with a lot of embedded devices or perhaps railway infrastructure, you can also see that cybersecurity can be a threat to consumer safety and health. And the attack surface is okay. And we're back. Right, IoT devices, a great example for where a lot of security issues exist. So the problems the EU sees is that there is a low level of security. There are too many vulnerabilities basically in products, and there's not enough security updates that would fix them. And also there's a lack of communication or information from the vendors. So there's no standard way of communicating there are security issues and these issues have been fixed, and it's really hard for a consumer to also make choices. Which product do I buy? Which one can I trust on the updates? Right. And what's the reason for that? There's basically little incentive for manufacturers and vendors to currently address cybersecurity, because if you think about the risks that are in your product and you have to do sandboxing or other thing that takes time in development, and especially IoT is the time to market very important. You want to be first to selling some kind of product to beat the competition. Also, all the time you spend on security and not making the main functionality work is time that you have to pay for. There's additional cost, which also makes your product more expensive and, in the eye of the simple consumer, less attractive. And if there is a CV, then there's little repercussion for the vendor. The consumers might not even have no bad image. There's little strings attached to basically being insecure in many cases. And yeah, so the EU uses law and legislation to enforce levels of cybersecurity, which will be mandatory. And in a nutshell, if you have to describe it in a sentence, basically, more focus has to be put on security during development. That means assessing all the risks, addressing all the risks, describing the remaining risks, and also documenting all of it, making it plausible, keeping the documentation around. If the EU comes by and asks, where's your documentation? Do you comply? Then those documents have to be ready. And it's not just in the development, but also manufacturers have to, for at least 5 years, care about the products that they do release. You might also think of devices that launch and then never see an update ever again. That's not allowed under the CRA. For at least 5 years, you have to check for vulnerabilities that affect your product, fix them, and also communicate about the issues. The law is decided, has passed, and will go into full effect in December 2027, so that's a little over 2 years until every product has to comply. And in about a year, the vulnerability reporting will become mandatory, so that's a bit earlier and not that far until then. What's the effect on NixOS? And perhaps the good news is that, as we know it, not directly. So NixOS is an open source project. There is money involved with the foundation, but it's a non-profit organization. There is no commercial activity around NixOS, so the Cyber Resilience Act excludes specifically such software, and basically all the duties do not apply. Well, who does it apply to? And just in general, it's specified as products with digital elements. You can think of it as anything that somehow can connect to a network. Is it software or devices? If it somehow can connect to the internet and is sold in the EU, then it has to comply. For example, in the NixOS context, if you build an embedded device and use NixOS as the operating system, then you have to comply. If you ship your laptop and buy, design or install NixOS when shipping, then you're kind of selling NixOS with that, and you become responsible for ensuring CIA compliance. And also, if you make a commercial activity somehow out of NixOS, then the particular vendor becomes fully responsible of taking over the CIA compliance and security updates and everything that comes along. Okay, so in such cases, somebody was to use NixOS in the CRA context, then the perhaps good news is NixOS, with its reproducible build approach, is quite CRA friendly, I would say, certainly more than other distributions. And there are many points that you could mention here. I picked out these 3 topics, which are strong points, but also not as much. And we'll just go through. You get to see a few in particular requirements of the CRA and connect it to NixOS functionality. Yeah, we have 14 minutes now, and it's a bit to cover, so don't expect super in-depth information. It's more of mentioning a few things and giving you pointers for discussion or further research. Okay, so updates, especially security updates, they're mandatory. We talked about it before. And first point is security of the updates. That's not specifically mentioned in the CRA, because basically everything about the product has to be secure and integrity has to be ensured, things like that. I just want to mention here specifically for the updates and how NixOS does its updates. So let's see, what's the process if an embedded system, for example, decides to check for updates? Then it looks at its channel or source, hopefully over HTTPS. If you use HTTP, then you will have a problem. But you get it from Git or a tarball somewhere. So you receive that securely. In there, you have all the source hashes in the derivations. And also the packages that you do not build yourself, but retrieve from the binary cache, they are also signed. Yeah, so that's covered basically. Also, the CRA requires updates to be automatic. You don't want to wait around for users to update their devices. This will usually take too long, or they might skip. So by default, updates, and especially security updates, have to be automatic. That's easy to do, you might say, within your Nix configuration. That's true, but then again, it gets a bit more complicated. The EU, in my opinion, is really consumer-friendly in that way, and it tells you that the updates, while automatically enabled, have to be postponable, and also you can disable them if you want to, if you have a particular reason to not take them. So yeah, but that's an issue of implementation. You can work around there and implement it somehow. Okay, another alternative I want to mention, which is also more common in the embedded areas where you want A/B updates, so have one version installed, install another one alongside, and then basically if anything fails, you can use your original version further. There's systemd sys update. That's not NixOS specific. It works with other distributions as well, but it is compatible with NixOS, and I've linked a GitHub project there with a really simple example of performing updates and everything configured in NixOS configuration. Okay, next topic is SBOM and CVE monitoring. So for everybody who doesn't know what is an SBOM, it's short for software bill of materials, basically a list of all dependencies that your system or software brings along. And the CRA states that you need at least a software bill of material that contains all your top-level dependencies. And that's the basis for which you have to do your CVE monitoring. Look for vulnerabilities for all the components that your software or system consists of. And what's really cool is that you can build that in a very nice automatic way with NixOS. So you have the packages all built by the derivations that specify their inputs, and you can basically build a tree, walk through all the dependencies, get down to the very last package of what's included. Even all your build dependencies, not just the thing that end up in your NixOS image, but down to the compiler that was used to compile a piece of binary. It's the question if you want to track that or not, but it's possible. You can get all the information. And there are tools to do that. I want to mention here the SBOM Nix tool, as well as Bonbon, also very nice names. And okay, how do you continue from there? You have your software bill of materials, and now you somehow have to check if vulnerabilities occur for those packages. And yeah, the thing is, it's complicated. It's not just for NixOS, it's for everybody who does this kind of task. So basically, you have vulnerability databases. There's the NVD, National Vulnerability Database from the US, that seems to become kind of unreliable. So there's now the EU VD and also other open source vulnerability databases, such as the GitHub Security Advisory. And yeah, basically new vulnerabilities are published there, and they're usually tagged with either CPE, as it is with NVD, or EUVD, which stands for Common Package Enumeration, like CVE, but for software packages, or a package URL. And both of these have their strong points and weaknesses, but basically it's tricky to match or find out if a vulnerability applies to you, especially if it's coming from another ecosystem. So the Debian guys or Red Hat have a vulnerability and they report it relative to their package manager, which version it is, and also dates back to Debian version so-and-so. And now you look at your NixOS package and ask, is it the same version that I have? Am I affected? Am I not? And yeah, the problems start even earlier. You might not even have the correct CPE or Perl for your package, there are ways to guess them or predict, or there are lists being maintained. I've linked one here that's used for mapping NixOS packages to CPEs. But overall, it's a mess, and everything is basically trying to not miss any vulnerabilities, and you end up with a lot of false positive of things that do not affect you, but the algorithms are not sure, and they just mention there's a matching vulnerability. There's a project that's NixOS specific and goes into this direction. It's currently in the prototype stage in the Nix security tracker. Just a short mention here as well, because that's exactly the direction. And finally, a short discussion of long-term support. So you might know this is not a strong point. So what would be a motivation for long-term support? Like we said, 5 years at least of security updates, keeping packages secure. And well, with NixOS, you can take your release and it will be there for, 7 months. And after that, you don't get new CVEs, or it will not be maintained anymore. And as a vendor, under the CRA, this can be problematic, so you can try switch to the next release. Again, might be lots of work and time that you do not want to spend, but especially you might have problems if they're breaking changes, too much is different, and you can't get a functionally equivalent new version of your product, so you have to ship it as an upgrade, and at that point, CRA says, oh, this is a new version, and users have effort to upgrade it, so no, you have to also maintain the other version, keep it secure, and that's problematic. So for industry, the easiest thing is to develop your product once, and then basically just make sure it stays secure, but not have any functional changes. So from that perspective, long-term support would be great. If you look at the other side, at the people who actually care or maintain the releases, it's the opposite. So short release cycles are a benefit there. So what do you have to do to maintain the release? You have to be on top of the CVEs that occur, and you have to backport the security fixes to a specific version that you support. And that's all right in the beginning. There's not much delta between your version and the newest version. But over time, after a few years, the newest version of some software might be quite a bit different than your current one, and it will be tedious to port back some security fix. Or you might not even be sure if it affects you or not, because so much has changed. And further, the NixOS package set is huge, and doing so much backporting for such a large package set is, let's say, problematic at least. And then that's finishing off now. The stable version, sometimes mistakes do happen, and they're not as stable as one would hope. So a few weeks ago, there was this problem where the extra kernel config was renamed and should just be unstable, but it made its way into the stable release. And there was no warning either. Your config just didn't apply anymore. So, which would not be ideal for commercial activities. Thank you very much for listening. We have like 2.5 minutes for questions, and after that, feel free to talk to me over the weekend and share your thoughts on the topic. Thank you.
Will you upload your slides to pre-docs?
Yes, that's the plan. I have to do some exporting and HTML things, but that's the plan.
Hi, thank you for a great talk. I was curious what the scope, like a little bit more clarification on the scope. You said anything that has a digital, like runs software essentially. So for instance, I was thinking like, if you get a managed Kubernetes cluster on AWS, will everyone have to go and say, no, don't upgrade my Kubernetes cluster without telling me, or like without me triggering it, because it's a digital element, for instance?
Yeah, good question. So there's many edge cases. Not quite sure about your case, but as soon as you basically provide some software in a commercial sense, then you have to comply. There's something that goes in the direction is like software as a service. If you just host software on your machines and users run the software in their browser, then you're actually fine with running whatever on your machine as long as it's just in the browser of the user. So it's a fine line and you always have to check.
Question, yeah, how is the CRA enforced?
Yeah, that's a good question. It depends. So it depends on the criticality of the product. And usually for most products, I think like home device or something non-critical, then you basically keep track of all the documentation internally, and you might be at random checked, or if there's any occurrence, you might be checked. There are, however, more important products and operating systems fall into this category: sandboxing, hypervisors, firewalls, things like that are considered important or critical, and in that case, third party or certificate is necessary before releasing the product.
Okay, I think our time is up, so let us give our speaker another round of applause. Okay, are we ready? Do we have the technical difficulties sorted out? Apparently not. Well, I can still introduce you. There we go. Okay, so let's give it up for Josh. He's going to be talking about Nix-based development environments at Shopify. I'm sorry about that. Like, only for me. I mean, you can also have this one, I guess. Yeah, that's what I'm gonna do. All right.
Pass the mic. Okay. All right. So, not sure who heard what, so I'll just start over. Hi, I'm Josh. I work at Shopify. I'm on the developer environments team. For those unfamiliar with Shopify, it's an e-commerce platform. It powers a sizable chunk of e-commerce online. If anyone was here in 2019, you might be getting deja vu right now because a colleague of mine, Burke Libby, was here giving effectively the same talk, Nix at Shopify. And then we sort of went silent, and internally we backed away from Nix. And so what happened, Nix hadn't fully reached kind of a stable footing, and it didn't sort of have like a huge amount of buy-in from leadership. And so then there were some pockets of developers that were like not supported super well. And then there was this big company shift, I think in about 2020 or so, where it's like we're all going all in on cloud development. And since Nix wasn't really in like totally stable footing, it just got pushed to the side, and you know, the feeling at the time was like, let's just use Ubuntu. Like, surely that's good enough. Let's just do this from first principles. And then, I mean, you can tell because I'm here now that that didn't go amazingly well. You know, there's positives and negatives, but you know, so now 6 years later, we're back. We're doing Nix again, and I hope to sort of share some experiences of migrating over again, you know, what we did a bit differently this time, and like what went really well, maybe things that we shouldn't have done differently, and just sort of, yeah, maybe, you know, hopefully be helpful for any company that's looking to move over to Nix. So a quick background on development at Shopify. We're predominantly a Ruby on Rails shop. Most development happens on Darwin, but we have a giant number of developers, and so there's a bit of everything at the company, like a bit of Go, a bit of Rust. It's like really everything, right? And I mean, I say we predominantly are Mac OS. There's a lot of Linux developers as well. And I can't share official numbers, but this is a screenshot from Wikipedia. You can probably estimate the number of developers yourself based on their estimate of our employees. Hopefully I don't get in trouble for sharing that. The primary tool that we provide as the developer environments team is this tool called Dev, and it's sort of the single tool that you use to get set up on every project. And that's been at the company since about 2016. So there's a buttload of code bases, and kind of the guarantee is that you can just run dev clone for some project. It'll clone the project, and then you run dev up, and it'll do whatever setup needs to happen for any ecosystem. Up here, I've got a kind of an example of a dev YML, and see it kind of explains itself. You know, you list out some packages that'll install some system packages that could be homebrew or apt or, well, now Nix. And then, you know, okay, it installs Ruby 3.4.5. It runs bundler and installs a bunch of Ruby dependencies, and then it sets up your database. It might do some like database seeding and stuff as well. And so, rewinding back to 2024, this was kind of a very pivotal moment for us. We were just really dissatisfied with everything. You know, we had been doing cloud development for about 4 years, and it just kind of sucked. It just never really felt good. And then we moved back. We're like going back to working on macOS locally. And now we're back using Homebrew. And it's like, this just kind of sucks for us as well. We try out dev containers and like VMs running on macOS. Also just sucks. There's this whole initiative where we're moving towards a monorepo, and then we've like tried Bazel, and that didn't really work well for the Ruby ecosystem. So it's just like everything sucks. Like, what's going on? We're like looking around. We're like, you know, do we suck? Is the problem us? And like maybe partially, but around this time, the CEO discovers Devenv. And he just goes and applies it to one of our internal code bases, this project called U2. It's kind of like our internal wiki. And, you know, like it was a really small Nix program, like, or, you know, like this is basically what the devenv.nix looked like. And it's like, you know, it just worked. And he did almost nothing, right? And he's like up and running on Nix. And like, it was like, this is amazing, right? And he's like just in love, and he's like up and running on Nix. And like someone's got to sell the vision to get Nix into the organization. And in our case, Devenv kind of did it for us, and the CEO just discovered it on his own and really yeah, fell in love. So thank you, Devenv. Amazing, did an amazing job of sort of selling the vision. You know, what's really great about it is how it doesn't hide Nix away in the background. It doesn't try to just make it like an implementation detail. It's really like it puts Nix front and center, and you know, and people can kind of fall in love with it and kind of progressively get into Nix rather than trying to hide it away. And so we're looking at that, and we're like, man, should we just throw out Dev at this point? Like, we've had our own internal tool for 9 years. Devenv is like amazing. Should we just be using it? And we really did try this for, you know, like a solid month or so, just trying to really make Devenv work. But what we started to realize is like we have our own tool. It's existed for about 9 years. It's got a lot of its own kind of legacy, like quirks and implementation details and stuff. And so reconciling all that with Devenv without like polluting a bunch of garbage into Devenv would have been difficult. And so what we did instead was we just went and bolted Nix onto our existing tool, Dev. I guess I don't really need to talk about the benefits of Nix here. I'm sure everyone knows. But you know, if we're just going to go bolt Dev onto Nix, like that's what we did last time, right? And that didn't go well. So like, how are we going to try and avoid it this time? Like just falling into the same pit. And you know, the big thing that like the major reason why it failed last time was probably just due to an overuse of Bundix. For anyone that's not familiar with Bundix, it's the like 2Nix for the Ruby ecosystem. It takes all your gems and turns that into like Nix, builds it into the Nix store. And that's amazing for when you're packaging a Ruby application, but not super developer oriented. And I'll give a tiny background on building Ruby dependencies here. A lot of Ruby dependencies will include the like vendor C code, have their own sort of ad hoc build system around test, there we go. So they'll vendor their own C code, they'll put some sort of ad hoc build system that's of kind of like nebulous quality, and then you'll compile that just locally on your machine. Most of the time that is not pre-compiled, so like on our main code base, that can take like 10 to 20 minutes to compile on a developer's machine. And so that's slow, and so you can definitely see the temptation to pull that into Nix, but for a very important subset of developers, compiling is a feature. We have a team of folks at Shopify that will work on Ruby, that'll work on Shopify's dependencies, and so they're like working at deeper layers of the stack. And so when we first pushed it out, we were using Bundix, and we sort of pulled everything into Nix very aggressively, and we set up this hard boundary where it's like, if you want to work on Ruby or you want to work on Shopify's dependencies, like you're kind of screwed, right? Like, you don't really have much recourse. And so that really angered a lot of people, or like a very important subset of people. And you know, the Ruby team is amazing. They really are, you know, they're just hacking on every layer of the stack. They really embody like your dependencies are your code. And so on this reattempt, we wanted to make sure that these guys were happy. So our strategy was to avoid Bundix, meet developers where they're at. We just didn't really want to like change too much. Ideally, people should kind of be able to continue using dev as they know it. Just run dev up, and then it'll just, instead of using Homebrew, it'll use Nix. And we wanted to migrate projects incrementally. We've tried doing like wholesale migrations where we like flip the entire company over to a new thing all at once, and that hasn't gone super well. So we really wanted to make sure like projects could migrate one at a time. And then, we do eventually want to include or to use Bundix and start pulling some of this stuff into the cache, but we just wanted to make sure that we sort of like step into it, and at every point that we're pulling things in, we have ways for people to opt out, so that if they don't want Nix pre-compiling these things, that we can, so that they have a way to opt out and hack on the thing directly. And then the last thing that we really wanted to do was just prove it out on Shopify first. It's kind of our biggest, largest, baddest code base. We didn't want to just like focus on toy examples and like get that working and then try and push it out into like harder and harder problems. We just wanted to like run into a brick wall as fast as possible, prove it out, and see if it worked. And so that's kind of what we did. Well, I'll skip over this. There's lots of decisions to make when you're starting out, and the short of it is like none of it really matters, and it's important to understand like what you're picking when you're picking like your cache and your build farm and your front end and yada yada. But like as long as you're not painting yourself into a corner, it's not too hard to pivot from this stuff. So I'll quickly go over the pipeline of like what it looks like to get to use Nix on a user's end. So you would just run dev up, and then we take your dev.yml, we translate that basically into a set of or sort of like a spec that we then pass over into Nix. Basically, like it's slightly different, but we're effectively just running Nix print devenv with that spec. We pass that JSON into Nix. Nix then turns that, it'll like print out all the environment modifications that it would make. We then translate that into this thing called shadowenv, which is kind of our version of direnv, which just like tweaks your environment variables for you. And then we do everything else. So it's sort of like that sets up the foundation with Nix, and then then we go install services and like seed them and yada yada, install dependencies. Yeah, so it's really quite simple at the end of the day. And so that got us to like the seems to work phase. And then we moved on to trying to get this working on Shopify, and then we hit like a lot of hell. There's just like complications everywhere. Like we need to set up LD library path wrappers for FFI for Ruby so that it can find all the dependencies, and then like a lot of a lot of programs will just say if macOS, you're using BSD sed and like call it a day, right? And that doesn't work if you have a GNU sed, which I think is what Nix provides by default. Then we're hitting like Clang things and yada yada. And then we're like, we should really be sandboxing gem installations that, when it's compiling, we know that it's not accidentally hooking up to opt homebrew. So we turn that on, and then we discover like another giant pile of problems. And so then we'd fix all that stuff, we'd update Nix packages, we'd update Shopify, everything's broken again. So we just do this on repeat for like a month or two. And eventually everything stabilizes. The main lesson here is that sandboxing is really good. Definitely use sandboxing. It's pretty obvious. On macOS, use sandbox exec. On Linux, I don't know, like mount namespaces or bubble wrap or something. I think there's a lot of options here. So yeah, we've stabilized our main code base, and then we're looking at rolling it out. And the first thing we did was we just got Nix installed on every person's machine and just providing a couple basic tools like Git. And this actually had its own like mini hell with like code signing problems and like background services and stuff if you're running Git maintenance. So do this part progressively. Like every stage of the rollout should be progressive because or like incremental, because you'll be surprised at some of the hellish things you'll run into. But yeah, so we got that stabilized, then we do the rollout in Shopify, and ultimately it just looks like Nix true in the dev.yml. This is the whole PR. That comment I think was from like some shitty bot or something. So we roll it out in Shopify, and then we hit user environment hell, which is just like every person at the company having some crazy setup that just kind of happened to work. You've got like some users that are like accidentally setting dial-D library path for some reason, and then nixseg faults. You're like, what the hell's happening here? And then you've got some people setting their gem configs differently, so then it like compiles differently and like forces linking to homebrew, and like just chaos everywhere. Just like so many like little things that happen to work. NeoVim people have like their own package manager, I guess. It's just like endless problems. So it was a good like month or two was just spent like bashing out all these things and like adding more and more warnings into our program so we could like flag when people are doing.
Yeah. So whatever I have learned in my first few weeks with Nix, and how can I apply it to teach other people in the organization? So it also documents that. So I have tried to create some metaphors, some glossaries, things like that, which I will show you. But how it all started was with this. A colleague of mine, he typed Nix shell. And then after a whirlwind of messages like this later, there was just a shell which was free from pollution, no more works, it works on my machine kind of analogies, and if something breaks, you just exit the shell. It was like pure magic to me, because it was the first time I was not scared to install packages in the system without pollution or without thinking about, oh, it will go wrong, or I will get thousands of error messages. So this is where it all started, and like Alice, I was curiouser and curiouser. Then what I did, I started small. So how do we start small? When we try to learn a new technology or a new language, we start with Hello World. So I went back to the basics of Hello World. Hello World actually helped me to understand what is the difference between Nix shell, Nix build, and different kinds of terminologies that you have in the Nix world. For the first time, I wrote a Nix derivation. Although small, just for Hello World, but it gave me the confidence to start working with Nix derivations. All those whirlwind of Nix store messages that we just saw in the previous slide, now I got to know what do they actually mean and where they come from. So another thing I got to know about was like, what does purity actually mean in terms of builds? Earlier, I had no idea, or I did not pay too much attention. But this time, I saw it in action. With Hello World, I went back in time. So back to 2015. What you see in the background, although not very visible, is the three-dimensional model of a city of Netherlands called Delft. It is created with the help of a software called 3D Fire, which is an open source software by TU Delft. It takes nothing but the point cloud data, the 3D LiDAR data, and then transforms it into a three-dimensional model, a semantic model. I worked with it, and installing the dependencies with the conventional methods was a hell, was a nightmare, because it had dependencies of Seagull, GDAL, Last Tools, Boost, and also some specific versions. And if you forget one, you will get an error that you are not able to build the software from scratch. With Nix, it was done in 15 minutes. I used the same example of Hello World, and I tried to build on top of it with the dependencies for this tool. Actually, I thought about going back to 2015 and starting again with this. But I couldn't, but at least I got to know, and I saw it in action, that how you can build from a small Hello World example to a real-life software, and then you can actually use it either for your personal projects or at work. So this was something that I tried to do myself, and then as you build on top of it, I went from what's a derivation to let me write one at work. I use Nix again for setting up the environment, this time at work, for a very tiny thing, not that big. But still, it's a Gazelle plugin to generate some target definitions in Bazel build file. It's called Aries. I tried to use Nix to set up the environment for development for this tool. And then I also was like, OK, let's go one step ahead. I also tried to use it for building and packaging the final binary. And then I saw it in action. Oh, how does my binary lands up in the Nix store? And how I can use it from there? So these were like key aha moments for me. But they also made me do some sort of self-reflection on the learning curve that I had to go through to go from what's a derivation to let me write one at work. And when you do introspection, sometimes you don't do it alone. You do it with the people, right? So you like to verify what you are thinking actually makes sense. Or do other people also think the same? Here, you see the graph of people. So at ASML, we have 3 build teams. And then I talked to people about what I was thinking for my learning curve. And then I got to know that we have 3 kinds of users at ASML for Nix. One, I call them are passive users. I was one of them. And you see them in orange here. These are passive Nix users who do nothing and just do Nix shell on their command line. Then we have some people in the green up top. I call them active Nix experts. Or I should say, I call them Nix listen algorithms. And my people in green, the Nix listen algorithm, are also here in the room. They're sitting on 1, 2, 3, 4, 4th and 5th row. They helped me a lot in learning what Nix is, and they were always available when I had questions. But you see the people in blue. I call them stuck zone people. And they are the people who start their journey from orange zone to green zone, and it's like a steep jump. I am myself, how should I say this? I'm in stuck ++. Yeah, and that's true, actually. I've only learned up till the part of derivations. What are derivations? How can I write one? But still, there are so many topics of Nix which I haven't explored yet. So I would still call myself stuck ++. And there are many people like that who are in stuck ++ in the company. Here you can see only one, I think, yeah, because this is the data for the build teams. But yeah, it's a very steep jump. And I asked them the questions, like, why do they think it's a steep jump? The first thing they said, oh, I don't understand what the derivations are. I don't understand the language. I don't understand the syntax. So beginners, like it says here, they often try to learn everything at once. But they get overwhelmed by the technology, basically, by the terminology, and also by hard to read messages and outputs and all these kind of things. So what can we do to help them? What can we do to move the people from the stuck zone or from the passive zone to the experts? So here, what worked for me? Hello world, basic examples. Resources, some of the resources like some tutorials, videos that I saw, they are at the end of the slide deck, not really nice to see, but the one that I would like to mention is Awesome Nix. So it's a list of all the things which are Nix related, and you can actually visit the site, and you can actually choose, right, whatever you want to see. It's a big collection. And then having a glossary at hand, nothing fancy schmancy, the way I call it. No fancy schmancy, plain English, plain terminology to start with. And yeah, this one is my favorite, metaphors to relate. How should I say this? Like when you are 4 or 3, you try to make relations between objects, right? That, oh, this is this kind of ball which is used in cricket, or is it a baseball ball, or a soccer ball, like that. You make relations based on the object at hand. So I like to call them metaphors to relate, which you can use even with the technology. And yes, like I mentioned, the last thing, documenting to help the others, like whatever you learn, you document properly. And the help from the listen algorithms of Nix, basically. So, glossary. Why I love glossaries is because you start at the same base. You start with the same common understanding of terminology. And it helps you think, okay, you know the same thing, I know the same thing, we are talking the same language. So that's how they help, and I have started to create a glossary at work for all the Nix-related terms, but no fancy schmancy. Simple terms. Next. Metaphors to relate. Okay, I have a question, just by the show of hand. Can you tell me who of you play video games? How many of you? Yeah, I expected that. I also asked the people at work if they play video games. So this also helped me to draft the metaphors to teach them. Because if you have like 30 minutes of session at work to teach people what Nix is, what are the concepts, you would like to fully utilize those 30 minutes without overwhelming your peers, basically. So I did nothing special. I'm a 90s kid, so for me, it's all about being retro. I remember the cartridges and the console that I used to play with my dad here, like this. So I tried to explain these concepts in a very simple manner. We start with reproducibility. What is reproducibility? In simple terms, it's your game cartridge, right? You plug and play. You always start with the same game. So it's the same with Nix, right? You always boot the same game, no matter where you play. So as simple as it can be. Next. This is something I think you all could relate with. Multiplayer setup, right? Yes. You save your game settings to a file, and you share it with a friend. You do the same with Nix, right? So it's like shareable configurations, similar concepts. Next. This is my favorite, power-ups. On-demand packages. At work, we have well-defined configuration files, but sometimes I also like to do Nix shell -p, my own package. I call them power-ups, although they are not available in the defined configurations, which everyone uses, but sometimes you need some. So this is how I explain to people what are those on-demand packages are. Then, yeah, my favorite, Nix store. It's an inventory, right? As simple as it can be. Like every package, every item, every game is stored in an inventory somewhere. So yeah, and yes, because you also have to teach people, yeah, you are learning something, there is a skill tree, it's your learning curve. I know it's steep, but you can make it fun so that everyone starts at the same base, at the same level within an organization. But I know right now I have only talked about these simple definitions. Next one, configuration files. I know it sounds very silly, but they're spell books, right? Your shell.nix or your flake.nix, it's a spell book. And where do you specify what? Nix derivations, which are your like crafting recipes. It's simple as that. You tell Nix what to build, what are your ingredients, basically your dependencies, and how to build it. And in order to make them more relatable, you start here, which is your hello world. You don't throw people in deep waters at the beginning. You start with hello world, which is very simple. And right now, this is a work in progress. This is what I have learned until now. And I would like to extend this list with more relatable concepts when I move on to flakes or more, basically, one by one. So reflection on what I have learned so far. Okay. With all the experiments that I did, with all the aha moments I had, it was clear that Nix isn't just for beginners or for experts. It's for everyone. Anyone can start learning with it, even for a small project like Hello World. And I liked how it made all the experiments that I did very painless, repeatable, and fun. I wasn't scared of messing up the environments anymore, because I knew I can just do exit. It was as simple as that. But for now, I would say that I have gone from what's a derivation to writing one at work / for fun projects like that. So to newcomers or experienced users, mostly to newcomers like me, I would say that the learning curve is real, but so is the payoff. If I would have known about Nix in 2015, I would have used it, instead of messing up my system, installing the dependencies again and again. One thing I learned from today, after talking to several people here, I talked to people who are beginners like me, who have never used Nix like other people, and some of the very expert users who have been here and have given presentation on such advanced topics within Nix. So sharing experiences help, and I saw it here today, I'm standing here as a very beginner, right? And it has given me a platform also to share my experiences with everyone here. So I see how community plays a very important role here in improving the journey of the Nix users, whether beginners or whether they're advanced. So I would just say that it was super fun to be here and present this stuff, but if you have more ideas on how to extend the metaphors, the concepts, so that we can make Nix more accessible to the users, just please let me know. I'm here today, tomorrow, and not on Sunday. But yeah, this is it. These are the resources that I just mentioned beforehand that helped me. Awesome Nix, and to learn the Nix language, I used a tour of Nix, which is like an interactive way of learning Nix functional language. So these are the ones, and then the next is, yeah. That's it from my side, and thank you for listening. Thank you.
Okay, maybe some quick questions.
What are these? They contain the same content, right? They look like they appear to me as if they contain the same content, but they're two separate files. Which one is leading and when? So that was very confusing for me initially, but Nix documentation, the official documentation, it also helped me in understanding what are the difference between the two and when you use which one, basically. Thank you.
Okay, last very quick question. Okay.
Hi, yeah, thanks for the talk. I saw on one of your slides that you had kind of a table of contents, which looked like some very simple headings that would be useful to pass on to people. Is that just an internal thing you're working on? Or?
Is this the one you're talking about?
Yeah, that would be quite useful.
Yeah, right now it is an internal one, indeed. I'm not sure if you're going to open it to the outside of ASML, but I would love to do that. But yeah, I need to check it internally. Thank you.
Okay, that was our last question. Let's give our speaker another round of applause. Okay, let's get ready for our next talk by CJ Zhao, titled Life Without Kubernetes, hosting mirrors with NixOS. Let's give him a round of applause.
Test. Right, hello everyone. So it's very nice to be here, so let's get started. This is our outline today, so primarily in 3 parts. So first, about me, pretty brief, so you could look at that. I'm currently the president of our school's association on all tech things like JigPy. I'm also leading the school's Linux user group. I currently as the SRE role for our mirroring infrastructure as this school domain. I hosted the CEM meetup, so like in August 9th to 10th, so if you happen to be there, probably not, you might have seen me before. Yeah, so let's get started. So about our mirroring, what happens? So currently we have 2 machines. They all have Kubernetes enabled. One is called Milky Way, and the other is called Andromeda. The Milky Way is the server that provides public services, what you can access from the internet. It runs Debian Seed, which was Strixie, and now Forky. It accesses the Kubernetes control plane and worker node. This is the first machine. The other is Andromeda, which handles the storage. We have a ZFS reads that setup. It also runs Debian Seed, but it's only a worker node, not a control plane. And the third part is a in-house thinking backend we have. So we forked it from the Jiaotong University, which manages all the task life cycles. So like when to start, when to stop, what happens to retry, and all the kind of things. And it provides a RESTful API for the front end to query. Like when you open the site, it says like syncing is successful. Like when is it last synced? What's wrong? So the first part is about Kubernetes. Kubernetes is big, it's complex. There's a lot of new concepts to learn, like config map, there's service, there's namespaces, there's a path. And these itself are pretty hard to learn, but it also has a problem that Kubernetes is only suited for very large-scale deployments. Like 5 or 10 doesn't justify it. You would want like at least 100 or even 200. And also Kubernetes has a very complicated configuration in YAML, which is pretty bad. And so this is about Kubernetes. The next is about containers. Containers are impure. Like people might don't care, say that it works. It's kind of reproducible. It does the job, but containers are impure, and it's like not acceptable for us Nix people, right? And another part is containers have too much isolation. So our scenario, as I've introduced, is hosting a mirror website where our primary task is basically to just run rsync or a few git commands. And that is something that you don't really require data isolation, like separate networking namespaces. So that's like too much. And it's required by Kubernetes, so if we are to use Kubernetes, we cannot avoid containers. The next is about Debian seed. Like all other operating systems besides NixOS, it's hard to keep track of state. And because we use Debian seed, it's unstable, it's not tested. It's not like Arch Linux, which is still kind of stable and kind of tested. Debian seed is not tested at all. Debian has a bad documentation. Like, it's even worse than Nix. For Nix, it's like you have no documentation. For Debian, you have outdated documentation, which is even worse. It can be misleading, right? The next part is our in-house syncing backend. It tries to manage too much at a time. Like, it's a very long Go code, and the upstream is dead, so they're not using this. So we are now the upstream, and you don't want to maintain something that it's not what you wrote, right? So introducing Nix and NixOS. So Debian is impure, Kubernetes is too complicated, so we just use NixOS. And instead of using our own backend, we just orchestrate with systemd services. And this also gives us the capability of a declarative configuration as the single source of truth. So you just look at the configuration and you know what happens. And since container provides too much isolation, we just don't use them. We use plain old systemd service. And the bonus is that we generate all the services from Nix from our configuration, which I'll show later. This last part is that our syncing backend is pretty huge. So we just don't do so much. We let systemd handle all the tasks, and we just query the status via its dbus API, which is pretty easy to use. So next, about how we actually implement this. So this is a pretty simplified overview of the entire thing. It's very simplified, so we don't have multiple files for a different portion. There's only default.nix for everything. So the first part is how we implement a WireGuard network. So this is basically the implementation. It's pretty short. I think it's less than like 30 or 40 lines. And the nice thing is that we just import this .nix file, which can be a JSON file if you want, and generate this configuration, which basically just use systemd networkd to set up the WireGuard configuration. And the good thing is that normally if you want to create this kind of thing, you need to remember to, like we're doing something like a full mesh. Like, it's not exactly a full mesh, but it's kind of like, because we just filter out all the nodes beside our current one and set them up. So traditionally, if you want to do this kind of thing, you need to remember to update the keys every time you update nodes configuration, which is daunting and it's error prone, right? So this is our networking configuration, which basically is an attribute set of a list of nodes, and each node has this configuration about like what's its address, how to reach it. The next part is our syncing test, which is also pretty short. This is also simplified, so basically we just have a list of files that contains the test, and we just generate a systemd service for each one of those. We have this the data mirrors, which is our syncing directory under a ZFS reset pool. And your file is looking like this. So it's pretty simple. It basically is the start at is for systemd calendar, specifies how often to run. And this is a script you run. That's enough isolation for us. We don't need Docker containers. We just use this. And the last part is our Rust package, which is this is the syncing backend. So Nix has done a lot of hand folding, so it's very simple for us. We just use build Rust package and 1 line of cargo hash, and it works. And we have this. This is the main program. We use Rust, and Tokyo with Axum for providing HTTP service. We have this summary endpoint. It's a get endpoint that returns a status of the service with a schema predefined and compatible to our old implementation. And we just listen to this port. And this is like the core part that provides the service. So we use dbus that has a process macro to generate a proxy for like your debugs interface And you have this global connection state in storing as an app state, and you access the connection to connect to this, find this unit, convert it to a service, and you just query like, what's its last thanking result? You just check the exit status. When did it last finish? You check exit timestamp. And if you want to know exactly when, you can use Chrono to convert it into a familiar time zone, like Sun, June, like 23 or something. And the last part is like you want to know that has the thanking finished or not. So you could see to check for active state to see like if it's active or inactive, like starting or something. The last part. So what you have lost is the zero downtime updates and high availability provided by Kubernetes, because Kubernetes is like, I start a new deployment, but the old is not purged, and it's only kicked in until the new is ready. But our thing is like, you just let systemd restart the service, so you can't stop. But our school network is pretty bad. There's our occasional, or should I say frequent, downtimes. Like last month, I believe, we have like at least a dozen of times where each downtime is like 15 minutes or even over an hour. And the recent 2 weeks is like totally down. Like in every consecutive 24 hours, there's only like 2 to 3 hours where it's available. So our SLA is only have 3 nights or even less. Or you could say, you could argue that like 0.9% is also 1 night, right? Another thing is about scalability and other good cluster features of Kubernetes, like auto-scaling or etc. But we only have 2 machines, so it's not really useful because we don't use them. And the third thing is that our existing distro knowledge will not be applicable. Like if you use Arch, you could say that I have this very magical file in /etc, and if you edit that, you can achieve what you want. But in Nix, it's pretty hard, and almost everything is configured exclusively through Nix. So you need to try to look up in Nix documentation, which is pretty lacking, and try to find what you want, or just read Arch wiki to find what you actually want to do. But the good thing is I've been promoting Nix and NixOS among my colleagues, and I can say that most people are using Nix or NixOS or Nix Darwin right now. So we do have a big user base that they actually know Nix, so they can take over the maintenance. Now about the pros is that we have stable rolling updates. So Debian is stable, but the Debian is not stable. It's kind of rolling. Like it doesn't remove the old package, but it's not tested. And Arch Linux is not stable, but rolling. NixOS is stable and rolling, so we want that. And also it has easy rollbacks. Like you can just say NixOS rebuild switch rollback. But with other operating system, with other distros, you want to say like we have a B3FS snapshot or something with sub volumes. But with Nix, you just switch to a previous generation. And also we have unified and declarative configuration. So everything is in Nix, and you can share them across different configuration languages. For example, systemd has its own like INI-like format, and WireGuard has its own INI-like format. They're not the same format, so if you just use the 2 languages directly, you cannot share config. But if you use Nix, then Nix acts like a middleware between, like a bridge between the 2 languages, so it can share. And we also have code as documentation because Nix has an interesting feature that, like, if you just take a look at a brand new Nix code, you kind of understand what it's doing, but you cannot explain until you actually spend some time on it to understand. So this means that if someone is pretty new to our infrastructure, he can just understand basic idea of what happens just by looking at the source code. And then we can have our staff help him to learn more about the details. The last part is we have a lower maintenance cost. So previously we said that our thanking backend is forked from a upstream that don't maintenance them now. So our new backend is much smaller. It has only like 100 or 200 lines of code, so it's easier to maintain. And also the entire thing like entire Nixing is declarative and you have single source of truth. So you never like, I need to SSH into the server to find out what is our current state. We just look into the Nix. And deployments are simpler, and you just say use NH or NixOS rebuild, so it does that for you. What is our takeaway? So Kubernetes is not a silver bullet. Like I've heard ideas that Kubernetes, like you have like 5 or 6 machines, you should use Kubernetes, but that's not true. Especially if you don't have many nodes, you're just asking for trouble. Like you would spend a lot of time setting up Kubernetes, and you just don't have time to do actual work. The next part is that Nix and NixOS is not that hard. I've come across this word before called JSON++. I think it's pretty adequate for Nix because most of the time what we wrote, like it's just JSON with a bizarre taste and perhaps with some packages functions. But other than that, it's just plain old JSON. And if you really hate Nix syntax, you could just say that I have a JSON file and just import JSON read file and use that everywhere. So that's also kind of acceptable. And you don't really need to know functional programming to use Nix. Like, you don't need to know what is a monad. Like, that is not required. And the last part is that documentation is very important. So our old infrastructure has little to no documentation, but the newer one has Nix. Like, the code itself is documentation, and we also have additional documentation on like how you could get started to the entire Nixing and how you could deploy with that. Right. So some acknowledgement. I came across to Xidian University like last month, and I learned that they have already implemented this systemd service kind of thing, but they were in Python, and I take some inspiration from it. And that was a nice implementation, but it's not public, so it's shared privately. The next thing is to thank for Samuel DR. He has this nice background image. So there's a light one, there's also a dark one. I think you have seen this today, like morning in the aula. But I've used this throughout this slide and also as my own Mac's wallpaper. Yeah, so that concludes it. Wait, I have another thing, anecdote. I have an anecdote to share. So about this. So why I say Kubernetes is hard? So, okay, time is 4 minutes. So one thing is that our old configuration, like our mirroring frontend uses Nginx, and like I think 2 years ago, one of our previous maintainers want to add broadly compression to Nginx so we could serve compressed assets. But our Nginx config is stored in the config map. So you know that if you want to update that, the service uses the config map. So whenever you change the file, you need to sync it into the config maps and then restart deployment. And what we have is that everyone just modifies the config file. None of them synced into the config map. So we were always using the old configuration for 2 years. And when I changed the config map and switch, it kind of broke because our Nginx image doesn't have broadly support. And since no one used the new config map, they never realized this. So that's kind of a reason why we don't want Kubernetes. Yeah, so that concludes. Yeah, any questions? Yes?
I was wondering, when you were building up this new system,
Sorry, can you repeat that in the microphone?
Sorry, of course. When you were setting up this new system, what other, I guess, software systems did you consider? Like, for me, Ansible comes to mind, but I was wondering what you might have thought of alongside NixOS, or did you just jump into NixOS right away, or did you try other things?
You mean alternatives to NixOS, the entire solution?
Yes.
I've briefly considered Terraform, but I think their language is even worse than Nix. So, like, I know Nix is different from Ansible and other systems because Nix itself is a problem. Like, you have software dependence and all the Nix store issue. But I'm fairly acquainted with Nix, and I don't know much about Terraform, Ansible, or other solutions, so I thought it's probably better to just use NixOS. And also, I'm basically the only person who is maintaining, who is caring about this thing. So I have the final say. Yeah. Anyone else? Yes?
Do you know who set those 2 machines up with Kubernetes and why?
We used to have 3 machines, and they decided to use Kubernetes. I know it doesn't justify it. I have no idea what they thought at the time.
And did you ever have to do a Kubernetes version upgrade?
No. And I can say that I don't think anyone from our team knows how to do that. So we just use the old one. It works. Yeah.
Yep. Thanks for the insights.
So you could give the.
I have sort of a bizarre question. So you said you set up a WireGuard, right?
Yeah.
So if you have 2 machines, why do you need a VPN?
Right. So there is a problem that if we do have some service that has to be run in a Docker container, and we use OCI containers to set them up, right? But if you want to publish a port, it bypasses all the firewall rules. So everyone from the local school network can access it, which is not what we want. So what we can do is that we have this network, and we publish the port to the WireGuard IP. So you cannot exit from outside.
But yeah, you can manage firewall rules manually, so to say. So you don't say open port in this OCI configuration. I forgot what it's called. You don't specify the port there. Instead, you just write IP tables, commands. There is a way you can Google that if you want. So and I mean that's at least what I'm using, and that's pretty easy, and it works, and it doesn't require VPN. I was just curious about VPN. That's it.
I try to avoid using NAT tables or IP tables. Because if you know, I happen to have a firewall D Nix project, so I try to avoid those low-level things. And also, we have this, we have 2 machines, that one for storage, another for public service. So we have this NFS share. So it's also pretty better to if could limit the access to that WireGuard IP range, CIDR, right? So that would be useful.
Okay, I'm not sure if we have more time left. Yeah. So I'm gonna have to cut it off. So let's thank our speaker again.
Also war nicht gut fokussiert, ne? Also
Kannst du ja mal fokussieren. So, wie viele Bullshit-Folgen haben wir jetzt gemacht? Ich probiere es mal vor, mach's wieder an.
Oh, was ist der aktuelle IP des heißen?
Ja, die haben sich jetzt natürlich geändert.
192,
Okay.
Digital Zoom.
Keine Ahnung.
168, Punkt.
Nicht sicher.
88, 252.
So, und 88 finde ich schwierig.
Ja, das war der Default, der IP-Range. Ich glaube, der Router, den soll man wegschmeißen.
Mikrotik stand drauf, ne?
Ja, stimmt.
Das Ding ist gar nicht so schlimm.
Ja, aber 88 als Default-IP.
Ja.
Finde ich halt persönlich einfach schwierig.
Ja.
Wir brauchen eine Light-Source, die anbleibt für das Ding, ne? Für die Winkelkatze, damit dass man irgendwo was sieht, ob sich das Ding noch bewegt.
So, sieht das denn eigentlich gut aus im Momentan?
Ja, schick mir einfach mal, ja. Und der kann dann auch direkt so einen Wirecard oder so mit aufmachen und so.
Das ist der
Steuerung Shift P.
Steuerung Shift P. Gut.
Und jetzt ist aber Wirecard kann man auf jeden Fall einfach so einrichten.
Ja, die sind. Und ich meine, also Rotor ist das eigentlich schon ganz okay.
Nee, da ist das mit anderen Dingen.
Gut. Hast du die Dinger hier unten mal kopiert schon gehabt heute, die Dinger?
Nee, habe ich noch nicht.
Dann
Ich war seitdem noch nicht mehr da. Aber ja, mach mal.
Das ist jetzt identisch aus dem, was die OpenVPN-Leute,
Das ist so, das haben die, das wird der sein.
Gerne, danke.
Das läuft, wunderbar, funktioniert.
Ja.
Wir haben jetzt eine Winkelkatze. Wir brauchen immer noch eine Lichtquelle für die Winkelkatze, da habe ich uns überlegen. Aber das Licht geht dann nicht nach. Die Lampe haben sie unten. Auf der Garderobe.
Ja,
Da wo nur ich rankomme. angekommen.
Willst du die,
eine Kabel.
willst du die jetzt wirklich über Nacht
Ja,
hier laufen?
Die hat doch eine Kamera drauf.
Ach, du bleibst wach.
Ja, ist klar.
Hier und ist aufschlägt. Ja, gut. Explodieren die, oder?
Genau. Ich mache dann ab und zu mal so ein Nickerchen, ne? Ich mache nur ab und zu mal so ein Nickerchen beim Zuschauen.
So eine 8 Stunden Nickerchen.
Ja, haben wir hier nicht. Ja, wir wollten auch Licht ausmachen. Also, man sieht hier exakt nichts, ne? Wenn ich hier ausmache, kannst du da anmachen? Ah. Ja, lassen wir doch einfach so. Nee, lass an, lass einfach. Ja, es passt.